Good morning, all. Good morning, all. So, on behalf of all the organizing E and ICT academies, I welcome you all in this day 2 of 2 weeks online faculty development program on Internet of Things and Smart Systems, which is conducted from 14th to 25th Feb. So, today's first lecture will be taken by Dr. Arghadip Roy, sir. Good morning, sir. Before we start the session, we would have a small announcement. Today there will be hands-on session 1. For that, you all need to install OS in your Raspberry Pi board. The installation process is already provided to you in the Telegram group as well as in the drive. Also, we have uploaded all these steps. So we request you all to be ready with your Raspberry Pi board with OS installed on it by 12:30, because the hands-on session 1 will start from 12:30 onwards. So before we start the lecture 1 of today's schedule, let's have a brief introduction of our next speaker. Dr. Arghadip Roy is an assistant professor at Mehta Family School of Data Science and Artificial Intelligence, Indian Institute of Technology, Guwahati. He was a postdoctoral research associate in University of Illinois at Urbana-Champaign, USA. Prior to that, he received his PhD degree in electrical engineering from IIT Bombay. He received the BE and MTech degrees from Jabalpur University and IIT Kharagpur respectively. His research interests are in optimization and control of stochastic systems, resource allocation in next generation 5G and 6G wireless communication systems, and reinforcement learning. So with this short introduction, we welcome Dr. Arghadip Roy, sir, on this platform to deliver his lecture. Over to you, sir.
Thank you very much. Today we'll be talking about communication technologies for IoT. Let me share my slides. Is my slides visible?
Yes, sir, your slides are absolutely visible. Thank you, sir.
Okay, so thank you very much for inviting me, and good morning to everyone. So yesterday, I think there was an introductory session on this. Yeah. So yesterday there was an introductory session on this topic, communication technologies for IoT, and I think Professor Bhattacharya, he has talked about some of the technologies which are relevant for Internet of Things. Today I am going to cover the other technologies which are relevant to IoT technology, and this will serve as a continuation of the yesterday's lecture by Professor Bhattacharya. Okay, so I am Arghadip Roy. I'm from Mehta Family School of Data Science and Artificial Intelligence, IIT Guwahati. Okay, so as you know that Internet of Things, there are many devices which wants to communicate among each other. These devices could be placed in a very distributed manner. Okay, so and typically they do not have a coordination among each other. Okay, so essentially the IoT network could be in a very distributed fashion. And our goal is to develop communication protocol among these IoT sensors which are present in a distributed manner throughout the network. Okay. And there are many technologies that has been either created just for IoT, or some of the existing technologies that has been tailored properly to meet the need of IoT, Internet of Things networks. Okay. So, for example, many of you have heard about 3GPP. 3GPP is something called Third Generation Partnership Project. Okay. So 3GPP has developed certain technologies which are inspired by traditional technologies like LTE and 5G. Okay. So this development of LTE and 5G is basically one path that has been created by 3GPP, and then for the need of IoT, those technologies has been modified little bit, so that using little modification you would be able to set up a IoT network. Okay. So these characteristics and aspects, attributes that has to be considered while connecting IoT devices. I mean, basically while choosing the appropriate communication technology are as follows. One of them is range. Okay. So the idea is, for example, suppose you have heard about IoT, you have heard about, you know the basics of Internet of Things, but you want to set up your own network. Okay. So what is the criteria based on which you will choose the appropriate technology? Okay. So one of the criteria is range. So for example, if your devices are spaced very close to each other, then you can choose a technology which has a very small range. On the other hand, if your devices are very far from each other, okay, then you have to choose a technology which ensures that the range of the base stations or the uh, controlling coordination body should be large. Okay. Another important parameter is frequency band. Okay. So what do you mean by frequency band? Basically, as you know, this LTE and Wi-Fi and GSM, 5G, all these things have their own frequency bands. Okay. So for example, this 2G technologies like GSM, they operate in their own frequency band. Okay. Then 4G LTE, they have their own frequency band. Wi-Fi has a separate frequency band. So this frequency band becomes important because frequency band actually uh, tells you that what should be the uh, what should be your data rate and what should be your penetration power of the electromagnetic wave, right? Because as you know, in 5G you may have seen that 5G offers higher data rate, but it requires line of sight communication. Okay. So because and so therefore its range is not that great, but it offers higher data rate. So as you move to higher frequencies, you will get better data rates, but your range or line of sight requirement might be stricter. Okay. So if you have any doubts on whatever I am talking, please feel free to post in chat. Okay. So this frequency band is another criteria. Also, there are criteria such as power consumption. The power consumption is a very big issue while designing IoT network, because uh, mm, basically the IoT networks, you will see that they are placed in a very distributed manner, and they have some low battery associated with it. You cannot feed IoT devices with generators like base stations, right? So for example, in today's wireless base stations, you will see that there are generators or electric power supplies available that you cannot do with IoT. And you cannot treat IoT devices like a mobile device also. Mobile device you use every day, and at the end of the day you recharge it. But IoT device, for example, it is placed somewhere in a field or somewhere in a city, in a electric pole. Okay, so you cannot go and charge them over a single, I mean, every single day. So therefore, it is necessary that these IoT devices consume very less amount of power. Another important thing is topology. So we will talk about these things and how different IoT standards are basically cater to these problems. We will see. Okay. So in this talk, we will focus on the categorization of IoT technologies based on range and frequency bands. So these two will be the primary focus of this talk. Now, various technologies based on range. So range is our first criteria based on which we are going to classify different technologies. So for example, Bluetooth. Bluetooth is typically a short range technology. Okay. So as you might have already noticed that the short range of Bluetooth is generally less than 100 meters. Okay. So So for example, now if you want to set up a IoT network where range is a very important criteria, then you can go with Bluetooth, because Bluetooth is typically low cost and the range is 100 meter. Now there are medium range technologies also. For example, Zigbee, Wi-Fi, 802.11 AC, BGN, AH. These are newer standards. NAH. So 802.11 is basically the standards for. Is there any question in the chat? So so basically, Zigbee Wi-Fi 802.11 is the standard for IEEE standard for Wi-Fi technology. Okay, so you will see that the range of this kind of technologies are medium, and for long range you have to go for 2G, 3G, 4G, or 5G. This kind of technologies gives us a long range. Okay, so so this Bluetooth covers the short range, Wi-Fi covers the medium range communication, and NB-IoT, which is narrowband Internet of Things. Okay, that basically comes under the umbrella of long range communication. Okay, so basically what I want to say is, in today's world there are technologies that has been developed using different paradigms, and those paradigms actually covers the entire spectrum that has been designed based on the range criteria. Okay, so short range Bluetooth, medium range is Zigbee, Wi-Fi, and long range is 2G, 3G, 4G, 5G. Okay. So so one of the representative technology in this area is Bluetooth, which has a short range. Wi-Fi has medium, and NB-IoT, which is narrowband IoT, that has a long range typically. Okay, so in today's talk, we will pick one of the candidates from each of these boxes and try to cover them. Okay, so let's go with the Bluetooth low energy first. Okay, so Bluetooth low energy is as a IoT technology based on Bluetooth. BLE, it is called BLE. So Bluetooth is an important short range communication technology today. So so it's a frequency hopping technology. And at the rate at 2 gigahertz band. So it operates in 2 gigahertz band, and it's a frequency hopping technology. So what is meant by frequency hopping? Frequency hopping is basically your center frequency is now at some particular center frequency, and then after some time it goes to some other frequency. Okay, so it is basically a Bluetooth device. Basically, when it transmits, so initially for some period of time it transmits at a particular center frequency, and after certain time it goes for it hops to another center frequency, and so on. Just a question for all of you. Can you tell me another frequency hopping technology which you have studied in your wireless communication books? I am hoping that all of you are familiar with wireless communication technology. So can you name any other technology which uses this frequency hopping technique? You can post your answer in chat. But one answer, that is Wi-Fi. Any other? Ankit says RF. Sure. So RF is a very generic term. Any other answer? Zigbee. Another answer is from Jaya. It's Wi-Fi. CDMA. Okay. Prashant Sharma has CDMA. Balan wireless ad-hoc network. Sped spectrum. Okay. So I have got some Nagarajan as DSS. Okay. I have got some answers now. So regarding Zigbee, I am not sure because I don't know about Zigbee whether it uses, but many of you have talked about CDMA and sped spectrum and direct sequence sped spectrum. So basically, these answers what I was looking for. So in CDMA, you have known about direct sequence sped spectrum. Another thing is frequency hopping spread spectrum. So in CDMA, what happens is that CDMA transmitter receivers also operate in frequency hopping mode. Okay, so now you are at a center frequency, and then you are going to the senses, going to another center frequency. So that is applicable to CDMA communication, because one of the main purpose of doing this is to ensure security. Because if someone is trying to breach your communication system, then it is necessary that you keep on hopping so that it is unable to guess which center frequency you are in. So there is some protocol between the transmitter and the receiver. They know each other. They know what is the frequency hopping scheme, and based on that they go from one center frequency to another. Okay, so this is applicable to Bluetooth as well. Okay, so this is a standard protocol behind wireless speaker headphone in today's system, and the center frequency is 2.4 gigahertz, which is also known as ISM band. The channel is frequency hopping spread spectrum. Okay, so the modulation techniques that is used here is a frequency shift keying. Basically, there are multiple frequencies onto which the data symbols are sent. Okay, and then the range is typically 50 to 150 meters, and the data rate we get is 1 Mbps. Okay, so this is a kind of a guiding book if you want to design IoT system using Bluetooth. Okay, so Bluetooth low energy or the Bluetooth smart is basically a improvement over typical Bluetooth networks. It uses low power and cost, and provides similar communication range, and it is attractive for IoT kind of applications. Okay, so Bluetooth low energy is basically a improvement or a modification over the Bluetooth network with less power and less cost. Communication range remains similar, and it is attractive for IoT kind of applications. So what are the difference between classic Bluetooth and BLE? Okay, so classic Bluetooth is basically you will see that they have greater throughput. It enables higher volume of data transfer, ideal for continuous and streaming applications. Okay, so what are the classic Bluetooth applications you will see? One of the application is, for example, nowadays I think most of you are familiar with Bluetooth headphone. Okay, so for example, you are streaming YouTube in your device, and you are working in your PC, and then you are listening to YouTube music on your Bluetooth headphone. Now, this requires continuous streaming. Okay, so therefore the classic Bluetooth is designed for this kind of purpose, that even if there is a lot of data which is continuously streaming, then classic Bluetooth is good. But in IoT kind of applications, it will be different. In IoT, generally what happens is that there is, for example, consider a field. Okay, so in field you have placed many IoT sensors. Okay, so then what you do is basically these IoT sensors communicate with each other or communicate with a centralized body. Okay, so in a field, what will happen is that, for example, every 1 hour or every 2 hours, they will be monitoring the temperature, weather of the entire field, and then it reports to the centralized body. Okay, so therefore, in a field, it requires like sometimes it infrequent data transfer, and the volume is also low. Yeah. So this is the requirement difference between classic Bluetooth and Bluetooth low energy. That initially for the normal Bluetooth application, it has to be streamed continuous fashion, and for a Bluetooth for IoT application, it will not be continuous. It will be discrete, and amount of data is also low. Okay, so this actually motivates people to modify the Bluetooth in such a manner that this kind of technologies will be, this kind of applications will be served by them. Okay, so classic Bluetooth also requires device pairing, but BLE does not require that, and it is useful for wireless device streaming content such as audio platform, video, and data. And BLE is typically used for sensor devices sending small bits of data using little energy, as I was telling. Okay, so there will be another talk on this smart farming using IoT. I think there I will try to cover it in a more detailed fashion. But these are the application areas where BLE could be useful. Okay, so this is good for IoT applications, and it can run on coin cell battery for years. So for example, if you have installed a Bluetooth sensor in your field, then it will run for years using the just a coin cell battery. Okay, but classic Bluetooth, it is good for telephone earpiece, game controller, wireless keyboard, printer, and you see that this kind of devices sometimes require charging also, maybe not like it will to run for years. For example, if you have a Bluetooth speaker, you might see that that has to be that can work for 8 hours, 9 hours, or 12 hours at max. After that, it has to be charged because you are working with a continuous kind of streaming application. Okay, so yeah, so these are the differences. Okay, so now we talk about long range technologies. There are different two types of standards. Okay, one is non 3GPP standard and another is 3GPP standard. Okay, so there is a terminology associated with long non 3GPP standard that is known as LPWN. Okay, so LPWN is low power wide area network. Okay, so you know that idea, the entire idea of IoT revolves around low power. Okay, so if you have a wide area which is covered by the IoT network with a low power, then it is known as LPWN. So the goals are long battery life, low cost, and extended coverage. It's like typically like 10 to 15 kilometer in rural areas, 2 to 5 kilometer in urban areas, okay, and massive number of devices. Okay, and there are 3GPP standards as well. Okay, so non 3GPP standards are, for example, this LoRa and Sigfox, and 3GPP standards are LTE-M, EC, GSM, NB, IoT, 5G. Okay, these are 3GPP standards. So in today's talk, I'll be talking more about this LTE-M and this NB IoT. These will be the focus. But initially in this slide, I will just quickly tell what they are. Okay, so LTE-M is basically extension of LTE network to serve the IoT purposes, and NB IoT is the narrowband and technology based on LTE, which can serve the IoT purposes. ECGSM is basically some modification of GSM technology, so that GSM is also so that GSM or 2G technologies are also compatible with IoTs, because in some cases what happens is that IoT networks are generally required in areas where human are not reachable. For example, you are doing cultivation in a hilly terrain. Okay, so there human intervention is not possible, and sometimes in those areas 4G services may not be there, but 2G service may be there. So there is a technology called ECGSM, which basically utilizes this GSM kind of GSM or 2G ideas and modifies them to serve the IoT applications. Okay, so LTEM, we'll start with LTEM. So LTEM is a technology which is a 4G category M1 standard published by 3GPP in 2016 as a part of their release 13. Okay. So in release 13, 3GPP publishes this LTE 4G category M1 standard, which is known as LTEM, and it is a standard for narrow bandwidth cellular communication. Okay. So these are all 3GPP driven. Okay. So what happens is that connect resource constrained devices to internet and small amount of data over long time. That which I was saying, that typically IoT has these kind of applications that it will not send data continuously like YouTube or audio platforms. It will send small amount of data but over a very long time. Okay. And what do you mean by resource constraint? So for example, power constraint. Okay, power is one of the resources. Okay, so in wireless communication, what are the resources? One is your power, one is your antenna, another is your resource block, time, frequency. Okay, so devices are typically resource constrained in terms of power. So how to connect these power constrained devices to the internet is the goal. Okay, so LTEM basically maintains high signal penetration, and power consumption is also minimal. Okay, so it can work in areas where the signals are very difficult to reach. So and it is also power consumption is minimal. In release 13, the data rate has been set to 1 Mbps, and release 14 expects it to work in 4 Mbps. with mobility support and voice capability. Okay, so typically these are data driven like standards, but it supports voice as well. Okay, so that you can use it for voice purposes also. So these are the standard like requirements for LTE. And the main important thing about this is requires a new baseband software in the current LTE architecture. So if you look at the current LTE architecture consisting of base stations and then this PGW, SGW, okay. So in that current architecture, if you just include a single block, which is a new baseband software, then it will suffice. Okay, so this is a very important thing, because if you want to reuse LTE network and then you requires a lot of change, you require a lot of change in the LTE system so that it will be useful for IoT purposes, then that is not a good solution. Because that itself will take a very long amount of time. But if you can just do it in using some software, then it becomes very easy. It requires minimal changes to the current LTE architecture and your IoT network solution is ready. So therefore, LTEM is a very important technology in that sense, that it reuses most of the components of the current LTE architecture, and also it requires only software level changes, not hardware level changes. Okay. So features of LTEM is power consumption. So power saving mode, it goes to sleep when not in use. Okay, and there is no need of waking up for location update also in traditional cellular networks. It goes to sleep, but whenever there is a need of location update, then it wakes up and update the location to the base station. Okay, so there is a no need of this here. It goes to a long sleep, and this is known as extended discontinuous reception. Okay, so also EDRX. So so one question to all of you: do you know Are you familiar with this DRX concept? If yes, maybe try to answer what is DRX in 1 or 2 lines. Just the basic thing, not in great detail. DRX is a mechanism for uh, cellular communication technologies, discontinuous reception. Also, there is something called DTX as well, discontinuous transmission. These are power saving mechanisms. So, see any answer now? Okay, so basically, DRX is a technology of power saving mode. So whenever there is no data to send for a very long time, then what it does is basically it goes into a sleep mode. The device goes into a sleep mode. Okay, and sometimes it wakes up and just do some synchronization with the base station. Otherwise, the mobile phone remains in a sleep mode. So there are two kind of DRX. One is idle mode DRX. That means when there is no data going on, it is just monitoring the paging channel, whether there is an incoming call or not, or there is something called connected mode DRX. Connected mode means there is some session already going on, and within that, your data is intermittent. So there also you are going for sleep in an intermittent fashion. Okay, so this is known as DRX. This is the power saving mechanism which is already there in cellular standards, and this is in IoT. What we do is we go for an extended DRX. We make the long sleep, make the short sleep as a long sleep, because the data transfer requirements are also typically small, and therefore and you can save a lot of power. Okay. Coverage, you can use existing 4G infrastructure Okay, therefore it ensures greater coverage and better indoor penetration than LTE. Okay? So it has a better coverage and better indoor penetration than LTE, because in some of the cases the applications are indoor, right? For example, smart home or smart city. There are sensors throughout the indoor network, throughout the home, throughout your different parts of your home. So therefore, if there is a technology which is based on LTE, that has to have a good indoor penetration, otherwise it will not work. Okay? And then it can handle plenty of interference from building and other obstructions as well. Okay? So these are the key features of LTE-M, that it has a greater coverage than 4G, and it can handle plenty of interference from building and other obstructions. Okay? So it is basically tailored for indoor purposes. Okay, the data rate mobility. It has the high data rate and less power because of the support of this eDRX kind of features. The power consumption is typically less. Data rate is also high, and latency is 10-15 milliseconds, and it supports cell handover as well. So, for example, if there is a very low mobility kind of scenario where your IoT sensors are mobile, then it can handle basically cell handover also. It can go from one LTE-M base station to another LTE-M base station. The handover is possible. Okay, so most of the features of traditional 3GPP wireless technologies like handover, DRX, these are there, and some of the concepts are little bit modified to fit good for the IoT purposes. Okay, so it can handle plenty of interference from building and other obstructions as well. So applications of LTE-M is significantly lower cost than cellular system. It provides benefits of cellular system plus something else, and the application areas are smart meter. For example, you have a smart meter in your home. Okay, it basically calculates how much energy consumption is happening in your home, and these are connected to internet, measuring in energy consumption, water or natural gas consumption using IoT protocols. So, for example, there is a water company which serves water to your home, and then there is a sensor which basically measures how much water you are using. So this kind of technologies do not require frequent transmission of data, because whenever water is being used, then only it will send some data, right? So this kind of home applications, home appliances like smart meters, which measures how much electrical consumption is happening or water consumption is happening, yes, their LTE-M is instrumental. Another application is smart city, which involves intelligent public lighting. So you might have already seen this intelligent public lighting, that in the night, if you are walking through the street, you will see that all the lights are off, all the street lights are off, and whenever you are walking, a pedestrian walks in, then the lights gets on, because there are sensors, and it basically captures that, okay, basically captures that, okay, one guy has come to the vicinity of my coverage area. So so this kind of applications, LTE-M is very useful. Monitoring environmental conditions, checking availability of parking lots. Okay, so whenever you are trying to park your car, then it checks that whether parking lots are available. So these also can be done in a sensor-based fashion, and LTE-M serves as an very important technology. Okay. Healthcare also, medical treatment outside the hospital, and personal IoT devices like fitness wearable. This is a very nowadays a very important instrument. It is there with almost everybody, that you wear a watch and then it monitors your heart rate and how much steps you are walking throughout the day. So this LTE-M is a good application for this purposes also. Smart watches. I think there will be another session by Dr. Niob where he will talk about smart watch and smart wearables, and probably smart city, smart home, this kind of applications will also be treated in a separate talk, I think, in the next week. So applications of LTE-M are varied. It involves healthcare, asset tracking. For example, this Amazon, when it delivers, then where is your asset? Sometimes it can be driven by a sensor-based thing. So whenever your package is being transmitted from Delhi, for example, and then it will reach somewhere Mumbai. In between, whenever there is some IoT sensor, it will scan the barcode of your product and then send you updates. So for this kind of applications, LTM is very useful. Wearables, automation, smart city, and smart meter. Okay. So any questions anyone have for LTM? And post in chat before we start narrowband IoT. We'll just take a 1 minute or 2 minute time to see if there is any question from your side before starting NB-IoT.
So in case if you have any queries, dear participants, please let us, you can raise your hands. We can unmute you also so that you can have an interaction with the expert.
Chat. Something chat, I'm not understanding the question.
So
Syed has posted some. Sorry.
Okay, yes, sir.
Yeah, so Syed has posted something in the chat, but I don't understand the question. So yeah, if there is no other question, we can move on to the next topic.
Sir, one participant has raised her
Okay.
hand. So can I
Okay,
unmute
please.
him?
Yeah.
Yeah, Nageshwara Rao, sir.
Sorry, ma'am. I have raised a hand in around 9:43.
Okay. Sorry. Yeah.
Yeah, so there is one question, Lte and Volte difference. Okay, so yeah, so Volte is basically voice over LTE. So that is for the voice part, and LTE encompasses everything. LTE is basically the data and voice together. So LTE is the first technology where data and voice both are both uses packet switched net, packet switching. Both uses like there is no dedicated channel. Okay, so previously there was for voice there was a dedicated channel and circuit switching, but and data uses a shared channel which is known as packet switching, and then both of them has been clubbed together, and then that is known as LTE. In LTE there is no circuit switching, only everything is packet switching. So Volte is basically the voice part of it, and rest are basically handled by data. So by Volte you mean the voice is also transmitted over LTE in the packet switched manner. Okay, so this is what is known as Volte. Okay, so another question is how IoT can be integrated with SDN. See, the SDN concept is basically software defined network. That is typically it talks about centralization. Okay, so now if you want to design a system where there is a, for example, this LTEM system only, its LTEM base stations are controlling IoT devices. Now if there are many LTEM systems and you want to control the entire network in an optimized fashion, that there are, for example, 10 LTEM base stations. Each base station covers for example 100 users, 100 IoT devices, and then you want to do an optimization on an SDN controller which is connected to all these LTEM base stations. Okay, so it's a hierarchical network. The SDN controller sits on the top. After that there are 10 LTEM the LTEM controller sits on the top, SDN controller. After that there are 10 LTEM base stations, and then the users. Okay, in this kind of applications actually it can be integrated with SDN. Okay. There is another question, which Bluetooth module is better, HC05 and HC06 for power consumption and range point of view? I do not know the details of HC05 and HC06. I do not know the details of these two modules, so I cannot say. But I think if you just go to the specification, it will be easy for you to find out at what are the power consumption and range of these technologies. There is another question, that is to utilize the LTM service. We have to pay to the cellular operator or not? What is the operating frequency band? Okay. Yes, I mean it will be, I think, similar to the current LTE network. So current LTE network, you are taking a subscription from Vodafone, Airtel, etc. Right? So in LTEM also there will be some operators, and you have to be in one of the operators. And operators will typically participate in this licensing for this bidding for getting license of the spectrum, and then it will provide service to you. So you have to subscribe to some operator, and then they will give the service to you. Operating frequency band, I think, is similar to 4G, but those I will tell in the upcoming slides. It is there. Okay. No other question. I think I have answered all of the questions, whatever was there. Can IoT, okay, another question is, can IoT used in 5G deployment? Yes, definitely. There are 5G standards also for IoT, and they will they will like coexist. 5G and IoT will coexist in the future. So I would suggest everyone to keep eye on third generation partnership project website 3GPP, and you will get lot of updates. There are frequent meetings of different governing bodies, and then based on technical reports, then you will see that how this standardization is going with time. This kind of discussions are there in their website. It's a standardization body for standardizing mobile communication as well as IoT. This is also part of mobile communication. Okay, so let's move on. Narrowband IoT, which is known as NB-IoT. Okay, so low power, it's a low power wide area network solution provided by 3GPP. So this term I have already explained to you. Okay, so it connects to devices with requiring low bandwidth and small amount of data and improved battery life. It is based on LTE. Simple modifications to consider the use cases of IoT to extend the coverage and low power consumption. Okay, so it uses OFDMA, orthogonal frequency division multiple access, in the downlink, and single carrier FDMA in uplink. So this is basically very similar to LTE stuff. Okay, and LTE also uses OFDMA in downlink and SCFDMA in uplink. Okay. So NB-IoT operations, it operates in the same frequency as that of LTE. Okay, so LTE licensed whatever frequency it uses, it operates in the same frequency, and it uses Qpsk modulation scheme. So Qpsk is basically something like this. You might have already, yeah, all of you are familiar with this. So this is the constellation diagram, and then there are constellation points present here. You can connect them by a circle. Okay, so this is your Qpsk, and typically this kind of applications uses lower modulation scheme, because if you just do a BER versus SNR plot, you will see that if you use a higher modulation scheme, then the bit error rate also increases. So in IoT kind of applications, since they are like already small but power constrained devices, you cannot afford to lose much data and cannot do retransmit again and again. So, and data rate requirement is also very low. It's not like you are streaming YouTube or something. So low data rate requirement, therefore it uses Qpsk modulation scheme. It's a low data rate modulation scheme, and it occupies a narrow band 100 128 120 kilohertz bandwidth, which is same as the one resource block in LTE. So in LTE, one resource block is 180 kilohertz, right? So it uses only 180 kilohertz. Therefore, it can be called a narrowband technology. Okay. In normal LTE, it can use multiple resource blocks. So therefore, it can be wideband. But here, it uses only one resource block. So three possible operation modes depending on location of blocks within the LTE spectrum. One is standalone mode, one is guard band mode, another is in-band. So for example, this is standalone mode. Standalone mode means when cellular service is not present, then also you can work. So for example, when LTE is not present, LTE services is gone, or it is, yeah, so that time what will happen is basically you use the GSM. Okay, so this I was saying that in a field application where there are 4G and 2G coexisting, so it might happen that the 4G service is not there, but the traditional 2G service is still there. So what you do is you reframe one or more GSM carrier. So you club them together so that it satisfies the requirement of IoT application, NB IoT traffic, and then there is a smooth transition to LTE for massive machine type communication. Okay, so whenever there is no LTE present, then also it can work in standalone mode using the reframed GSM structure. Okay, so this is the idea. Also, it can work in guard band. It can work in guard band mode. Guard band mode means if the cellular service is present and NB-IoT is present in the guard band of LTE carrier. So in LTE carrier, there is something called guard band. Okay, in the extreme left or extreme right, there is something called guard band, which is basically to minimize some ISI and other related some spaces left. I mean, those carriers are not used for data transmission. So those carriers can be used for IoT because they are already not using the LTE. LTE does not use those carriers. Okay, so what will happen is that it will avoid interference from LTE, because in this carrier there is no data from LTE side. Therefore, if you send data using this carrier, then there will be no interference. That way it is good. And there is another thing called in-band mode, where cellular services are present and NB-IoT is present in the LTE carrier. It uses resource sharing. Okay, so so for example, it can use some frequency which is already being used by LTE carrier, but it enables resource sharing. It is cost effective and seamless for operators, because if you want to do this guard band mode, then you need changes to the cellular standards. But it does not require any changes, because you are using the same technology, same protocol, and you are allowed to send here, but you have to deal with interference and other stuff. Okay, so no hardware change is required, and it is on demand spectrum usage. Whenever there is a demand, then only you use this thing. Whenever there is a demand for IoT data, otherwise you just remain silent or go for eDRX. Okay, so NB-IoT operations are half duplex frequency division duplex FDD mode. So half duplex is basically either you transmit or you receive, and FDD means your uplink and downlink are separated by different channels. So there are two modes. One is FDD, another is TDD. In FDD, uplink and downlink is separated by frequency. In TDD, it is separated by time. Okay, so NB-IoT uses FDD mode, and the maximum data rate is 60 kbps uplink and 30 kbps downlink. Okay, so this is very low data rate application. And the link budget is 164 dB. So basically, that means that if you are transmitting with this 164 dB, then you can cover the requirement in terms of range and other factors. And GPRS link budget is 144 dB. Okay, so therefore, there is an additional 20 dB link in link budget that basically gives us improved signal penetration and battery life. Okay, so the signal penetration is higher because it has additional link budget, basically, and therefore and the improved signal penetration and battery life. Okay, so NB-IoT is basically uses low power. Using power saving is a combination of power saving mode and eDRX, similar to the LTE-M. Latency is less than 10 millisecond. Battery life is less than 10 years. Coverage is something around 164 dB, and therefore it uses a low bandwidth, which is only 180 kilohertz bandwidth using of the LTE spectrum. Based on whether it's a guard band or in band, it can be either placed in the extreme left of the subcarrier of a chunk, or it can be placed in band along with the LTE LTE carriers. But you have to deal with possible interference issues if it is an in-band solution. Okay, so NB-IoT uses different channels, as that physical channel is converted, is segregated into two parts, downlink and uplink. Okay, so you will see these channel names are very similar to the LTE channel names. For example, in downlink there is something called broadcast channel, which is known as NPBCH. So in LTE there is something called PBCH, which is physical broadcast channel, and here it is narrowband physical broadcast channel. Therefore, it is known as NPBCH. And there are dedicated channels. So this broadcast channel is basically sending system information. Okay, similar to LTE. And dedicated channel is for sending data. Okay, so there is something called narrowband physical dedicated control channel, narrowband physical dedicated shared channel. Okay, so the physical downlink shared channel and downlink control channel. So these are dedicated channels, and uplink channel is random access channel. NP-RACH. In LTE, there is something called PRACH, which is Physical Random Access Channel. Here it is Narrowband Physical Random Access Channel. Okay, and there are dedicated channels as that narrowband physical NBDTCCH and NPUSCH, which is narrowband physical uplink shared channel. Okay, so there are channels are basically, if you just insert the word N in front of the existing channels of entity, you get this, and these channels are also very similar to the physical channels in LTE. Only difference is that it is modified to some extent to basically it is modified to some extent to cater to the IoT needs. Okay, so power saving mechanism is present. These are extended CDRX and IDRX operation. CDRX is for connected mode and IDRX is for idle mode. Idle mode means your phone is basically it is not conducting any call or any session. It is just staying idle and sometimes listening to the paging channel. Okay, and CDRX has been connected, is already connected, and then also you are following some connected mode DRX. Okay, so the extended DRX cycle length is 5.12 seconds and 10.24 seconds are supported. And idle mode, the extended DRX cycle can be up to 44 minutes for LTEM, and for NB-IoT it can be even longer, up to 3 hours. Okay, so up to 3 hours your device can go to sleep and then wake up and then do the operation. Okay, so there are certain problems also. If you go for very long DRX, it may happen that you miss some of the events, earlier events. So therefore, or you miss to transmit something, if something something happens which is not very usual. For example, you are monitoring a system and then some unusual event happens when you are in a DRX cycle, then it may happen that the report of that unusual event becomes little delayed. Okay, so therefore very long DRX cycle is also problematic. But in here you are doing a trade-off between some delay or missing certain events versus power saving. And this is a very important research areas also. So people, some of you might be interested in conducting research in the IoT. So this kind of designing a good DRX cycle, which basically balances certain trade-off between the power saving and delay. That is a very important research direction. Okay, so NB-IoT versus LTEM. Okay, so this is some comparison between NB-IoT and LTEM. NB-IoT is less powerful in terms of speed, data transfer, mobility, and NB-IoT use cases are smart agriculture, smart city, smart home, smart meter, as we are saying. So this is less powerful in terms of speed, data transfer, and LTEM is better suited for application with very low latency. Okay, NB-IoT better suited for low energy consumption and high reliability with coverage challenges. And the NB-IoT latency is on the order of 1 to 10 seconds, and LTEM latency is 100 to 150 milliseconds. So NB-IoT is not good for speed, I mean, in terms of mobility, and it is mostly used in smart agriculture, smart city, this kind of applications. LTEM is better suited for application with very low latency. And NB-IoT, because you can see this NB-IoT sleep cycle is also very high. Okay, here it is less, so therefore it is more suited for low latency communication. NB-IoT is better suited for low energy consumption and high reliability with coverage challenges. Okay, so latency is in the order of 1 to 10 seconds, and LTEM latency is on the order of 100 to 150 milliseconds. See, here the latency is also less because the DRX length is less, so latency is also less. So these are the very important factors in future research areas. Okay, so NB-IoT has no full support for mobility as opposed to LTEM. LTEM supports mobility, NB-IoT does not support mobility. NB-IoT more prevalent in use cases with stationary devices. So when the devices has very limited mobility or very stationary, then NB-IoT is mostly useful. When the device has mobility, then LTEM is useful. The limited mobility applications of NB-IoT is shared bicycle application, where there are a network of bicycles which can be shared. So bicycle mobility is basically low mobility, and application of moving component but less throughput. Okay? So there are moving components, but the throughput is less. And NB-IoT is more focused towards low energy than LTEM. LTEM, the energy consumption is not the main factor. It serves mobility. So in LTEM is basically more suited, more designed, more like in alignment with the existing LTE technology, which supports mobility and other issues. But NB-IoT is more suited for low energy communication. Therefore, the DRX cycle is also longer, and power consumption is also very less. The battery life is also longer, more than 10 years. Okay, so indoor penetration capabilities of NB-IoT is good. One NB-IoT base station capacity of 1,000 devices. Okay. So for example, smart meter in basements. In basements, narrow bandwidth allows better density of transmission power, and indoor penetration is also better in basement. Okay, therefore, NB-IoT is good in that sense. And NB-IoT is better for hard to reach application even underground. So because of its good coverage and low power, when underground where there is signal penetration is very poor or hard to reach locations, NB-IoT is a very important technology. Okay, so some table for comparison of NB-IoT and LTM. In LTM, the deployment is in-band, where in NB-IoT it can be in-band, guard-band, and standalone. Downlink and uplink, both of them uses OFDM and SCFDMA. Bandwidth of LTM is 1.08 megahertz and NB-IoT is 180 kilohertz. Therefore, indeed, this is a narrowband technology because the bandwidth is less. Peak data rate, someone was asking this question in chat. The peak data rate for LTM is 1 Mbps for downlink and uplink, and for narrowband, it is 50 kbps and 20 kbps. So LTM is basically having a better data rate. And duplexing method for LTM is FDD and TDD. For NB-IoT, it is only TDD. Only FDD. Okay. So these are the some comparisons. So as you can see, this NB-IoT is basically more suited for it. It has a low data rate, although because the bandwidth associated is also low. So this is very natural that it will have a low data rate, and it is more suited for low power application, and it is suitable for hard to reach or places where the signal penetration is not good. In those kind of context, NB-IoT is useful. LTM supports mobility. The data rate is also higher. So if you are going for a design a network where you need higher data rate and higher bandwidth, bandwidth requirement is not a problem. You can go for LTM. But where you have power constraint, then NB-IoT is a better option. Or you are hard to reach. You are in a hard to reach location, then NB-IoT is a choice. Okay, future IoT. The definition of IoT as given as ITU is a IoT is a global infrastructure for the information society, enabling advanced services by interconnecting things based on existing, evolving, and interoperable information and communication technologies. So in future, the information transfer that is going to see, maybe we need higher data rate, and therefore there is something called Li-Fi, which is light fidelity. And this uses a wireless communication technology that uses visible light spectrum. So in Wi-Fi, we use some 2.4 gigahertz or 5 gigahertz frequency bands. In Li-Fi, you use visible light spectrum for high-speed data transfer between devices, terminals, and servers. Okay, so in future IoT, we will see the application of Li-Fi that is under process, and hope that Li-Fi will play a very big role in designing future IoT networks. So that's all from my side. These are some of the references. And if you have any question, please feel free to unmute yourself or post in chat. I'll be happy to interact with you for some time. Okay, so question was, do SDRs have any role in IoT? SDR is basically software defined radios. I cannot say, I do not know the answer to this question whether SDR will be having a role in IoT, but intuitively what I can say is basically in IoT, software-defined radios might send some signal to the IoT devices, and those signals might be useful for the IoT device to do some computation in the device itself, and then maybe useful for deeper computation or greater computations at the base stations. Okay. So in that sense, it might be useful. Okay, another question is, can we design IoT gateway using SDR? So I am not very familiar with the SDR concepts being used in IoT, but yeah, as I was saying, that if your sensor devices have some limited intelligence, okay, then what you can do is you can use this SDR things to transmit some signals to the IoT devices, because these are software defined radios. So if you do not have a real network, you have a softwareized network, then based on the signal, the IoT can infer something and then process it in a local fashion and then send it further for improved processing. So that way it could be useful. Any other questions?
So one participant has raised his hand. So can we unmute him?
Yeah. Sure.
Yeah, Chintan Patel, we have unmuted you.
Good morning, sir. Actually, my question is, which layer these protocols work, LTE and NB-IoT?
So there are physical layer, as I was sharing, right? This physical channel. So this comes as a part of the physical layer, but obviously it does not end there. There are MAC layer protocols and network layer protocols also. So whatever protocol stack is there for the mobile communication system, like layer 1 and above, physical layer, MAC layer, network layer, and transport layer, all these layers has to be standardized when you are dealing with IoT devices. So correspondingly, there will be layers for LTEM and NB-IoT as well, all these layers.
Sir, thank you.
Other questions?
So next participant, Sujitra ma'am has raised her hand. So we have unmuted you, ma'am. You can ask the question.
Yes, ma'am. Thank you. Good morning, sir. Sir, if I wanted to,
Ma'am, your voice is not audible.
ma'am, can you hear me?
Yeah, I can
Yeah,
hear
now
you.
we can hear you.
Yeah. Thank you, sir. Thank you. Sir, if we wanted to cover 750 meters, which communication technology is suitable, sir? I'm in a position to receive the signal 750 meters. Yeah.
So 750 meter, I think, like if you just slides. .750 meter is basically a long range communication, what I feel. So therefore, you have to, you cannot definitely use Bluetooth based communication. Wi-Fi based
Okay.
protocols might be useful, but I think 750 kilometer is a big range. So
Sir, it is not
probably
kilometers, meters. 750 meters.
yeah, 750 meters you are saying, right?
Yeah, sir.
Yeah. Oh, sorry. So 750 millimeters means it's almost close to 1 kilometer. Okay. So it's a very high range application, and I think you should go with 3GPP based
So which one
technologies
will be
like
the
NB-IoT and
suitable
LTEM.
communication technology?
I think both LTEM and NB-IoT will suit your purpose. Depending on your power requirement, you can choose one of them. If your power requirement is stringent, then you should go with probably NB-IoT. And if you do not have much power constraint and your devices are mobile, then you can go for LTEM.
So what about LoRa, sir? Is it suitable for my application?
LoRa, I am not very sure about it. I mean, from today's presentation, I think this will be better. LoRa, I am not very sure about it. I have to take a look for answering. But I think it will serve because LoRa is also designed for long range purposes, so that should serve. But if you want to use these existing technologies like LTE, 5G, then I think LTEM or NB-IoT would be good.
Okay, sir. Okay. Thank you, sir. Thank you so much.
There is another question. What are the technologies to focus for keeping the energy efficiency of IoT centers? Thing is, so this was a question by Sunil Kamula. So basically, to answer this question is, first of all, we have to look at optimization problems also. Okay, only choosing the technology or protocols is not the answer. Sometimes technology protocol give you a baseline that where to operate, but if you optimize your system appropriately, then you will see that most of the problems are solved. Okay, so for example, you are working with an NB-IoT or LTEM system, and then you are working on a optimization problem where you keep energy efficiency is one of the optimization criteria. Then you will see that your solution that you arrive is basically catering to your problems. Another question is from Devashri. Any scope to work in this domain? I think there are a lot of scope to work in this domain. Mobile edge computing, smart city applications, and IoT, they are coming together. And then as one of you was asking about SDN, so in SDN there are a centralized control of IoT devices, and after that there are edge computings and fog computers also. And so therefore I think how to control itself, how to design an appropriate architecture is a big research area. And another area is, once you design an architecture, how your algorithm should run, that basically solves many practical problems or do optimization of energy efficiency and other stuff in a good in a well balanced manner. That is also a good focus area. Another question is, can you also explore this with respect to security feature implementation in LoRa? I am not very sure about the security feature part. This I have to check and tell you. I have not worked much about this LoRaWAN network actually. Okay. How about interference in NB-IoT? Right. This is a question from Dr. Muthu Subramaniam. This is a very good point that how to tackle the interference in NB-IoT while working in an in-band mode. Basically, in in-band mode, there can be an interference from other existing LTE devices. So definitely, this is a very good research area that can be pursued, and maybe one can come up with a solution where to use this. In some cases, adaptively you might want to use in band. In other cases, you might want to use the guard band solution. Okay, so this is a good research area. Is there any open source simulators to simulate NB-IoT? I think probably in Ns3 it should be doable. In Ns3 probably it has come with the IoT solution. You can check Network Simulator 3. Is there any IoT solution? This is a question from Naveen Kumar. Okay, so I think yeah, I have answered some of the questions. Already we are late by 8 minutes, so I'll conclude here. And if you have further questions, feel free to email me. I will try to address some of your questions. Okay, so thank you very much.
Thank you, sir. Thank you. Thank you, sir. Thank you for accepting our invitation and coming on board and sharing your knowledge with the participants. Thank you for joining, sir. So on behalf of the principal coordinator, Professor Ratnaji Bhattacharya, sir, I thank you, sir, for joining today and taking this lecture number 3.
Thank you.
So dear participants, we will start with our next session. So next session will be lecture number 14, which will be taken by Dr. Ashok Kumar Das, sir. Good morning, sir. Ashok, sir.
Yeah, good morning. Yeah.
Sir, we are giving you the presenter, right, sir?
Okay, right. Fine.
Sir, please give us 2 minutes.
Yes. বল ওই একটা টক আছে আইআইটি গুয়াহাটিতে 1 ঘন্টা কেন কি বলবে
Hello.
yeah, tell me.
Yes, sir. We have made you the presenter. So you can
Okay.
share your screen.
Yes. Like this. So is it visible that
Yes,
slide?
sir, it is. Yeah, it is absolutely visible, sir. So before we start the session, we will have a short introduction first.
Yes.
So dear participants, our next lecture will be taken by our next expert, Dr. Ashok Kumar Das, sir. So he is currently working as an associate professor in the Center for Security, Theory and Algorithmic Research in Department of Computer Science and Engineering of the International Institute of Information Technology, Hyderabad. His research areas include cryptography, network security, blockchain, security in Internet of Things, IoT, Internet of Vehicles, IOV, Internet of Drones, IOD, Smart Grid, Smart City, Cloud Fog Computing, and Industrial Wireless Sensor Networks. He worked with the CDOT New Delhi, India, as a research engineer in the switching software division during the period from March 28, 2000 to January 12, 2004. He played very important and crucial roles in the various projects mainly focused on the MTP3 layer, message handler and network manager, and MTP2 layer, data link control of the SS7 protocol stack design, development and enhancement activities. He has authored over 260 papers in international journals and conferences in the above areas, including 220 plus reputed journal papers. He has served as program committee member for many international conferences. He is on the editorial board of several reputed SCI journals. He also served as technical program committee chairs of several international conferences in the domain of blockchain and communication networks. He is a senior member of IEEE. He has been included in the subject-wise ranking of top 2% scientists from India, all fields in the area of networking and telecommunications, with rank worldwide by subject area 580, and also listed in the top H index for scientists in the world for computer science and electronics database maintenance by Guide to Research, with Guide to Research World Ranking 3242 and Guide to Research National Ranking India 21. We are glad to have him as our next expert for lecture number 14, Smart Grid and IoT. So with this, I hand over this platform to you, sir.
Yeah, so thank you very much for inviting me. So it is my pleasure to have a talk in front of this audience. So my voice is clear to all?
Yes, sir, your voice is absolutely clear and audible.
Okay, yeah. So let me to talk today that about some of the security aspects in IoT-based smart grid environment. So as you know that IoT is nothing but a layered networks of several smart devices, which are Internet of Things enabled devices, and which will be connected to internet. And also that those devices, which are called also smart devices, because they can take the decisions without much human interventions. And of course, in future, we are expecting that each and every devices, either it is physical or virtual devices, that need to be deployed in an IoT environment, they should take their own decisions. Okay. So the next questions come that once the devices are attached to the network, so they will produce huge amount of data. And in most of the cases, the data generated by the IoT devices, they are private as well as confidential. So hence the questions comes, how that we can make the data secure in an IoT based any communications environment. So in that line, So today we'll talk about some security aspects in IoT-based smart devices. And then I'll give a pointer that how this IoT-based smart devices security can be further enhanced in a blockchain-based that environment in order to enhance the security of the systems. So about me already introduced. So I did my PhD, MTech and MSc from Kharagpur. And my research interest mainly span on cryptography, systems, network security. And recently that our research team here at IIT Hyderabad, we are working on the blockchain as well as AI ML-based security. And some of the research highlights are there. More than 290 papers are published, around 250 journal papers are there, and most of them are in the highly top forums like IEEE Transactions, IEEE Journals, or IEEE magazines. So having that more than 11,321 citations, having H index as 61 and ITN index as 184. And some of the research papers are published in the top venues. For example, the topmost security journal is known as the IEEE Transactions on Information Forensic Security. Another topmost security journal is IEEE Transactions on Dependable Secure Computing. So our research team that has several top level publications in these forums. So next is that I have been also included in several editorial board members. For example, I'm the associate editor in the IEEE System Journals from August 2020 onwards. So also I have been associate editor of Journal of Networks and Computer Applications, Computer Communications. So recently I have been also included in the Journal of Cloud Computing from Springer, as well as Cybersecurity and Applications from Elsevier. So apart from that, I have some opportunity to have to be guest editor in several Elsevier as well as some Willy journals. So also that I have a media coverage. So if you are interested, you can have a look here. So that was published in the Times of India newspaper on 6th May. And this article emphasizes why the blockchain is so important for India and to secure the data, either it is the military data, either it is the banking data, either it is the judicial systems data. So anywhere that we require now security, and security can be enhanced with the help of the blockchain technologies. So then for more detailed information already introduced, so you can have my detailed information in the Google sites view IIT KGP Ekitas. So about some of the research collaborations is there. So I have worldwide good research collaborations. For example, Professor Sajal Kedas, IEEE Fellow from Missouri University of Science and Technology, USA. Professor Mauro Conti is their IEEE Fellow from Italy. Professor Willy Susile is their IEEE Fellow from University of Wollongong, Australia, and so on. So also that Professor Joel is there. He's my very good friend. So he's an IEEE Fellow from Brazil, and etc. Like. So now let us talk about that today in the talk. Security in IoT-enabled smart grid environment. So let me define first very briefly. So what is basically the smart grid? So a smart grid, which is considered as an electric network, so which can integrate that several users, also the several devices known as the smart meters. Along with you will have also something known as the service provider who will provide the service to the users or customer. So hence it can integrate in a cost-efficient manner the behavior and the actions of all the users that are connected to the smart grid. So in the smart grid environment, you will have the generators which will generate the powers. You will have the consumers who will consume the electricity. So the purpose of is to here to economically ensure the efficiency, sustainable power systems with high level of quality, and as well as most importantly, we require the security of supply as well as safety here. So in a smart grid environment, that smart grid that are the IoT-enabled devices, so which will allow the companies as well as households to produce electricity. For example, in your house, you can have the wind terminals, so which will generate the electricity, and you want to sell the electricity to other consumers through the existing network. So as a result, that smart grid can be viewed as an electrical grid, so which will include a variety of operations as well as your energy measures. So that could include your smart meters. You can have several smart appliances in your house. Also that you can have the renewable energy resources. For example, you can have the solar arrays. From there it can generate the electricity. You can distribute the electricity. You can also sell the electricity to the other customers and all these things. So therefore, in a generalized architecture of smart grid environment, so first of all, that you are having the electricity generators are there. So either you can have electric generator, you can have the wind terminals, so which can generate the powers, and there will be transmission systems by which your power can be transmitted. You can have several substations, and substations will supply the power to several vendors. For example, you can have factory, you can have offices, you can have your home, etc. So for example, you can have your smart home where your smart meter can be equipped at your home. The smart meter will basically record all the electric consumptions of your house, and smart meter can actually communicate with other smart meter as well as through the internet, other components in the smart grid environment. Say for example, when your electricity cost is more, that you may want to sell your electricity to other consumers in the network also. So the next questions come that whenever that communications takes place in the wireless mode, there will be several threats and attacks are possible by an adversary. For example, if adversary say, for example, you change some information in the smart meter and it can mount some attacks on the smart meter environment. Say, for example, in a smart meter, your say electricity pattern uses may be stored here. Say, for example, you may be in some long vacations, but your say, for example, your 1 or 2 say tube lights are only working at the home. So your smart meter should not reveal any information that you are not at home, so that your home may be physically threatened by the adversary. Okay. So in a specific architectures of smart grid, basically we are having 4-layer architectures in there. So in the first layer, that it will basically consist of the power generations modules, which will generate powers either from the generators, wind terminals, all these things. Then you are having the second layers. So here the service providers are there. So service providers will take the electricity from power generations that utility companies, and next that they can supply to the smart meters, so which will consider the third layer. And the last layer, that is the fourth layer, we are having the several end users, where the users can be your smart appliances, user can be your say electric vehicle, etc. Okay. So let us talk about here. So the security in the smart grid environment. So what that it is seen that is smart grid typically consists of the 4 components. So first component is known as the sensing unit. Second is known as the communications. Third basically component is the control, and fourth one is known as the actuation systems. And the smart meters that are basically the very crucial components of a smart grid environment. So which is consisting of both the sensing as well as communications module, where we are having your service systems from the service provider that will contain communications, control, actuations modules. So one of the use of the smart meter is rapidly increasing in the civil applications. For example, if you take the smart home environment, so where the smart meter can be used to monitor energy consumptions in real life, then the smart meter can provide the power pricing information to the consumers, so that other consumers can also take the power from your house, smart home through the smart meter that connected to your house. Now the next question is that, so what are the security aspects is this? So first of all, due to wireless natures of the smart meters. Say for example, if we consider any malicious activity by the adversary or known as the intruder or attacker, that attacker can not only eavesdrop or intercept the communications between the several components in a smart grid environment, but that attacker can have also ability to update, modify, or insert the fake informations on the transmitted message, say between communications service providers as well as smart meters. So again, that there is another question that your smart meter, they are basically installed in your smart home, and they are typically that protected by the physical locks. So therefore, your smart meter can be, you can lock physically your smart meter, but again, still that there will be some say possibility of physical compromise with the smart meter. For example, if there is an adversary who breaks the say physical lock and takes your smart meter, that adversary can apply something known as the say power analysis attack or say side channel attacks. So where the informations which are stored in the smart meter can be extracted. And using the extracted information, the adversary can impersonate easily other smart meters by means of compromising secret credentials stored which is inside in the capture devices. So therefore, one of the important issue in the security of the smart grid environment is that physical that basically capture of the smart devices. Okay. So once that smart devices are physically captured, the informations which are stored in the smart devices, they are also that physically that they are also compromised. And using the compromised informations of the smart meters, the adversary can also impersonate other smart meters on behalf of basically the those non-compromised smart devices in the network. Okay. So one of that aspect is that, so why we require the security in the smart grid environment? This is because due to that informations of energy used in the is stored in the smart meters, and they are distributed over say information on these side channels, and which will reveal that for example consumer behaviors and habits. For example, a user has several activities. For example, activities like say watching televisions have detectable power consumption signatures, etc. So another is that say for example your credentials privacy is another important issue in the smart grid environment. Say you are having your smart house, so where that some of the smart devices which will measure your say behavioral patterns, so how much energy that you have used at your home, etc. Those kind of credentials privacy also we don't want to reveal to outside to any attacker. So as a result that we are talking about here, that smart meters, which are basically the most attractive targets to an adversary, as the vulnerabilities can be easily monetized. So this is one of the that aspects that where we require the security aspects. So in order to that provide a variety of security services, for example, one of the very crucial aspects known as the credentials privacy. Therefore, the session key security, for example, prior to communications between say smart meter and service provider, they need to establish a session key for their future secure communications. So that session key can be used for secure communications, for exchanging the important informations between them. And for that purpose, we require to change the key that for each and every session, so that adversary even knows one session key that will not affect all the future session keys as well as all the basically the previous session keys. So as a result that we are having one of the property that your designed security protocol must be secure against the session key security, that one of the prime that concerns here known as the SK security. Okay. And also that along with that, we also require the something known as the secure mutual authentications. So prior to establishing a session key between two entities in the network, so they need to ensure that they are the genuine entity in the network, and then after only that confirmations, both the party will establish a session key authorization. So note that here all the communications they are over the insecure channels. So therefore, next question is that over the insecure channels, we need to establish a security protocol. So which will enable that to communicating parties in the networks to communicate securely over the insecure channels. So in this line that I will take one of the case study here. Say for example, this is one of the paper that which was published in IEEE Transactions on Industrial Informatics in 2017 by my graduated PhD students Mohammad Bajid and my research collaborator Professor Joel. So that work was on the secure three-factor user authentications in renewable energy-based smart environment. So in this direction, so let me talk about a little bit about the network model here. So what we have used that, suppose that we are having the power generator, which is coming say from the solar array. So solar array will store the renewable energy from the sunlight. Then this generated energy will be stored in some utility companies. Utility company will be connected to the internet, and you can have the several smart meters here. They are also connected to the internet. So in future, that what we expect that your all the vehicles in India and outside also there will be electric vehicles. Therefore, suppose say you are going for a long drive and you require say your vehicles to be charged. So what you need to do that. So having your smart devices or mobile device with you. So can you that establish a or can you design security protocols where your mobile device that will be enabled to communicate with the nearby smart meter to authenticate or whether a smart meter is genuine or not. And also the smart meter needs to at the same time needs to also ensure that the user coming to charge in this smart meter is also genuine. And only after the secure mutual authentications they can establish a session key among them. And using the session key, all the private or secure informations can be exchanged between the user as well as smart meter. And once that user is confirmed or assured, then the user can go to the smart meter, can charge his or her vehicles and go for long life. Otherwise, that without your mutual secure authentications, if user goes to some remote place for charging the vehicle, it may be that possible that your vehicle can be physically theft, etc. So there are several issues are there. So that's why this secure mutual authentication is very, very important in that case. Okay. So in that line, that what is that for designing any security protocols, you require something known as the threat model or attack model. So that will give that what are the capabilities of an adversary or attacker about your basically protocol that you have designed for this one. So we have used one of the very famous that threat model, something known as the Dolevio threat model. So which allows any two communicating parties to communicate over the insecure channels, and the endpoint communicating entities, for example, in this case, a user, smart meter, they are not in general trustworthy. And also the adversary under the Dolevio threat model not only can intercept or eavesdrop the communications in between them, but can also delete the informations, modify the informations, insert fake informations during the communications. So next is that, so suppose that user is having a mobile device, the mobile device can be stolen or lost of a user. So once a mobile device is lost from a user or stolen from a user, that adversary can extract all the sensitive information that are stored in the mobile device using say power analysis attacks, can use those extracted informations to say attack some other attacks, for example, impersonal attacks on behalf of the users. So next that we have used one of the current de facto very stringent that thread model known as the Sikhi adversary model. So which model that allows the adversary not only having all the capabilities of the Dolby or thread models, but it can also compromise private keys, session keys, and session states. So once a session is hijacked during the communications. For example, if an adversary say hijack a session, so for example, your security protocol say generate some secret random session keys during the time your the random secrets they are stored in the some temporary variables in that case. So those basically the random secrets can be also that compromised by the attacker by means of session hijacking attack. Then those kind of secrets along with the other secrets which are constituting as a session key between the two parties then can be revealed to the adversary. So as a result, so what we require that for if you consider any authenticated key exchange protocol, so one of the tasks is that can we guarantee that if there is a leakage of some form of secret information, for example, session empirical secrets known as the temporal secrets or session key, can they lead to compromise the other session key in the network that where that already established session keys they are created by the other parties in the network. So therefore, one of the goal of any authenticated key exchange protocol should be that it should be resilient against the Sikhi adversary model, meaning that if only the short-term secrets are compromised, then the session key compromise should not happen. So hence it is advisable that once you target to design any authenticated key exchange protocol, that your session key should be established using both long-term secrets as well as short-term secrets. So as a result, that even current session key is compromised by an adversary, that will not lead to compromise all the future session keys to be established as well as all the previous session keys that are already established and used in the communications. And that will enable to achieve both the forward secrecy as well as backward secrecy. So both the secrecy properties can be achieved by means of employing that kind of strategy. So in this direction, so let me to introduce very little brief introductions about the elliptic curve based cryptosystems. So an elliptic curve cryptography based on prime number generations, let p greater than 3 be a large prime. Then we are considering say a graph, say for example, y square equal to x cube plus x plus b modulo p, with the condition is that for a cube plus 27 b square not equal to 0 modulo p. And this condition is necessary to have the cubic equations, all the basically that the roots are distinct and unique. So together with that, we'll take a special point known as the point and infinity or 0 point. So hence that if we solve this equation and if we take all the solutions xy of this form along with this point of infinity, so that basically that set forms an abelian or commutative group under the modulo p operations. And this point at infinity or 0 point is taken as the additive identity points, and additive inverse of any point p is taken as the minus p equal to xp comma minus yp. And one of the properties that if your prime number chosen to be very large, then counting the number of points on the elliptic curve, that will be very time consuming task. It will take exponential time algorithms. But there is an approximation of these things is that by the mathematician Hasse, which tells the number of points in the elliptic curve, with lower bound p plus 1 minus 2 square root of p, and upper bound is the p plus 1 or 2 square root of p. Okay. So therefore, when the prime number p is to be chosen very large, an elliptic curve will have the roughly p points on it. So there are two kind of operations are defined here. So first is known as the elliptic curve point additions and elliptic curve point multiplications, or known as the doubling a point on the elliptic curve. So suppose that you are giving it 2 points, so P and Q having the x coordinate and y coordinate, so you want to add them. So what is the idea is that you simply draw a straight line passing through the point P and Q. Let the straight line be the touch at the point minus r, and if you take the projections or inverse of this point as the minus r to r, so that will give the additions of the 2 points P and Q. So this is a simple geometric problem. So if you solve it, so then what will do that when the P not equal to minus Q, that means that when P is not equal to the image of the point, another point Q, then lambda will give the slope of the line that passing through the points P and Q. And then you will get the third point R, which is P plus Q having the x coordinate and y coordinate as these values. But when the question is that when we are having only the single point P, so what you will do that you just draw a tangent line passing through the point P. Let this tangent say touch at the point R. If you take its inverse or image, that will give the doubling of the point, that is 2P equal to P plus P. So in that case, this lambda will give the that slope of the tangent passing through the point P. So therefore, here we are having the two types of operations here, elliptic curve point additions and doubling operations. And if we want to extend these doubling operations to the scalar multiplications by means of, say, having a point P and having a scalar K. So what we are doing that you are doing Q equal to K into P, which is nothing but you are adding the point P K times. So with respect to that, we are having three types of problems here. First is known as the elliptic curve discrete logarithm problems, which tells that if you are given the 2 points P and Q, such that Q equal to Kp, where Kp equal to you are adding points P K times, so can you determine the scalar K here? And this problem is very, very hard or computationally infeasible problem when the prime number P is chosen to be very large. So similarly, we are having another computational problem, which is known as the elliptic curve computational development problem. So which tells that if you are given the 3 points P, K1P and K2P, so can you compute the K1, K2P? And this problem is very hard problem because that to compute K1, K2P, either you require the K1 or K2. For example, if you can solve K1 from the K1P, then using K1, you can multiply K1 into K2P, you will get this point. But again, this problem that depends on the problem of the above problem known as the ECDLP problem, which was very, very hard problem, hence this problem is also very hard or infeasible. Another variant of the elliptic curve decision development problem is that if you are given a tuple, say for example, point P, 3 points K1P, K2P and K3P, where K1, K2, K3 are scalars, can you determine whether K3 equal to K1, K2 or not, or it is a uniform random value? Again, this problem that depends on difficult on the solving elliptic curve discrete logarithm problem, because if you can solve that K1, K2 and K3 from these points, then you can check whether K3 equal to K1, K2 or not. And in summary, what we are telling that all the problems, ECDLP, ECDCHDP and ECDDHP, all problems are equally computationally infeasible or NP hard problems when the prime number P is chosen to be very, very large. For instance, for elliptic curve cryptography, we need that at least prime number P to be 160-bit prime number, so that all these problems are really the computationally infeasible or NP hard problems. So now let me talk about what we talk about that about the proposal case study. So 3-factor user authentications for renewable energy based smart grid environment. But here I am only giving the high level descriptions. The paper is available, or I can supply you so that you can have a detailed study how it was developed. So this proposal consists of the 6 pages. One is known as the pre-deployment pages, which is necessary prior to deployment of the smart meters in the networks or service provider in the networks. which kind of information they need to be stored. And offline user registration page, prior to accessing any information by user needs to register with a trusted authority in the network. Then through the login page and authentications and key agreement page, the user will be able to authenticate other smart meter or, for example, something a service provider. And after mutual authentication, they can establish a session key among them for the future communications. So then the password and biometric update page is there, where the user can anytime for security reasons can also change the password as well as biometrics. Dynamic smart meter additions page is required when some of the smart meter can be physically captured by adversary and you need to again reinstall a smart meter at your house. Okay. So here that what we have done that in order to provide the replay attack protections. So what is the replay attack is that adversary, say for example, intercept message in between the communications, and after some time the same message will be again resent to recipient. If the recipient does not detect it that whether it is a old message, then what the recipient will do, the recipient will reply for that message. Then the adversary will again intercept that message and can get some of the informations during the communications. So in order to protect that what suggested is that we have basically used the random nonces, which is known as the random secrets, as well as current system timestamp in order to protect the replay attack. So that means that if your message attached with the current timestamp and if the message is received by the recipient, the current timestamp validations will assure whether your message is fresh or not. And of course, for this purpose, we require what is that known as all the network entities in the network should be synchronized with their clocks. Means the all clocks of the devices, they need to be synchronized, otherwise the timestamp mechanisms will not work. Okay, so that is one of the assumptions that has been taken where that network entities will be synchronized with their clocks. So for this purpose, we have used something known as the elliptic-based cryptosystems. So and for that purpose, we have used something known as the fuzzy extractor techniques for the biometric verifications. And in the fuzzy extractor techniques, we are having the two types of functions. One is known as the fuzzy extractor generations functions, which is a probabilistic procedures, which will allow to generate a secret biometric key along with a public reproductions parameter on a given biometric template. Then the fuzzy extractor deterministic reproductions procedures, what it allows that once you are having your current biometric template along with the public reproductions parameter which was generated from the generation functions earlier during the registration time, then it will generate or it will recover the original biometric secret key. And one of the fuzzy extractor generation functions that property is that suppose that at the time of registrations you gave your say some fingerprint at the time of registrations, but after say 1 month, so your fingerprint have some little cut. So there will be a little variant of the registered biometric as well as current biometric. So even fuzzy extractor can also authenticate you even there is a little variations in the biometrics. So for that what it uses something known as the Hamming distance between your registered biometrics and current biometric. So as long as the Hamming distance between your registered biometric and current biometrics is less than equal to some error tolerance threshold value, then it will be allowing to you to extract the original biometric secret key. So that's why that it is one of the recommendations that you must use that fuzzy extractor procedures for biometric verifications. Otherwise, if you use, say, for example, there are certain kinds of other biometrics procedures are there. For example, biometric biohashing is there. One-way hash function is there. They are not good candidates because they will generate a lot of that false acceptance and rejections that flags will be generated. Because if you want to use your one-way cryptographic hash functions, even there is a little variations in their fingerprint or, for example, biometric, that will produce the completely the new and random basically biometric secret key. That will not match. Okay. So what is suggested is that, so what we have done here in summary, so there is a pre-deployment phase where there is a trusted authority which is fully trusted, that authority in the network, whose task is to select the elliptic parameters, then your something known as the TH master key, the master secret key K, then the public key of the TA, that is known as the public pub of TA, which is known as the elliptic point multiplications, its pseudo identity. So here we are using the pseudo identity instead of using the real identity for security reasons, and also to provide the anonymity as well as untraceability property. Then T also that chooses unique identity for each and every smart meter deployed in the network, its corresponding pseudo identity, all these things. So then we are having something known as the user registration page, which will allow a user to register with the trusted authority TA. So for that purpose, user can choose a unique identity and can send over the secure channels, or for example, in persons, that user can give all the credentials, registration credentials to the trusted authority. Trusted authority will calculate some parameters. Then these parameters will be sent securely to the users. Then users will enter, say, his or her password, biometrics. So user can have the mask password instead of the original password. For that purpose, it needs to choose something, the random secrets, for example, known as the NI here. Then if you notice that all the pseudo identity and signature, so which is the signature generated on the random secret RI for the user UI, they are embedded here and hidden that with the help of the biometric secret key as well as the user identity, all these things. So the purpose of this is there. So even if your say smart device or physical, that is your mobile device, is physically stolen or lost, then the attacker should not be able to get your all the secret credentials. For example, even the attacker knows all these informations that getting RID from RID prime, it is stopped because it requires your biometric secret key. From SI signature extraction is stopped because it requires your biometric secret key as well as the random secret NI, etc. So once the user is registered, so what is that user needs to log into the systems in order to, for example, communicate with a smart meter. So for that purpose, that user will enter identity, password, and imprint the biometric templates, and user by mobile device will be able to calculate all the local parameters, and it will check whether the store CI star is matching with the calculated CI or not. If it is so, then mobile device will authenticate a user. Then only the mobile device will calculate other stuff. So for example, RI DTA, signature SI, AX RI star AI, all these parameters will be calculated. And here the T1 is the current timestamp, which is used for achieving the something known as the reply attack protections. And note that by this message, once even if that adversary knows this message, so impersonations of this message or man in the middle attack for this message is not possible, because that here that we have used that something secret known as the RIDTA we have used, and here X is also used, which consists of the pseudo password, biometric secret, of everything we have used here. And also that XI is there, XI which is the X.P. From X.P that obtaining X, that is the secret X, is computational hard problem due to elliptic curve, something known as the discrete logarithm problem, ECDLP problem. So once this message is received by the smart meter, it will check the presence of this message by means of checking the timestamp. If the timestamp is valid or message is not old one or fresh, then it will compute the RICI, all these things. It will verify the basically something known as the signature AI. So once it is there, so it will also calculate something known as another secret Y based on all these secret informations. Then it will calculate something detailment type of key known as the ZJ, and then it will calculate a session key SKIJ, which will be shared with the user UI. And T2 is the current timestamp generated by the smart meter. So once this message is received by the mobile device, then it will check the presence of this message, and accordingly it also calculate something known as the YJ, which is Detailment type of key, and it will calculate also the session key shared with the smart meter. So then it will also calculate something known as the session key verifier. So that will in form of something known as the acknowledgement AKI, so which will be equal to hash of session key and timestamp at this one. Okay. So once this message is received by the smart meter, then it will check that T3 is the current timestamp. It will check that whether the message is fresh or not. And since it has already calculated the session key SKIJ earlier, so then what will do that it will calculate the acknowledgement. So each of session key as well as T3. So then it will check whether the acknowledgement matches with this received acknowledgement or not. So if it is so then it will be the basically that confirm that the session key calculated by both the parties basically they are same. Okay. So then that we are having something known as the password and biometric update page. So which will allow a user to basically the change or update the password and biometric at any time due to security reasons. For example, if user feels that okay, so my biometric has been or password has been compromised, then what user will do that user having the mobile device can enter the old password, old biometric, and mobile device can verify old biometric and password if they are valid. Then user will imprint the new biometric as well as new password, and based on that, all the parameters will be computed, and all the existing informations in the user mobile device will be basically updated. And this page has been implemented in such a way that that it does not require to communicate further with the TM. So that means that local validations is also fine. So it will work perfectly okay, because in this case, mobile user is basically updating all the informations locally in order to avoid the high communications computational cost if the user each and every time needs to communicate with the basically the something like the trusted authority. So then you are having also the dynamic smart meter addition page. So or if some smart meter is compromised, then you can TA can basically assign a new identity and pseudo identity can calculate, and all these credentials can be stored in the new smart meter part to deployment in the networks. So then it is shown that this case study that security scheme is able to sustain replay attack, man-in-the-middle attack, impersonations. So privilege insider attack is one of the attacks, so which will allow that even your trusted authority is, say, for example, fully trusted, but some of the system administrator of the TA can still use your informations for some other reasons. So for that purpose, even your system administrator knows your some of the information that are stored in the, for example, your mobile device. That fellow also, as well as also the registration information, that fellow cannot derive your the password, biometric, and other secrets. So that is guaranteed by the design of the protocol here. So then you are having something known as the ephemeral secret key leakage attack, which is providing the session key security. So if you look at the session key constructions is such a way that so session key is consisting of both the temporal secrets as well as random secrets. So therefore, even if your temporal secrets are compromised, the session key is not compromised, because X and Y that which has been computed here that consists of both the long-term secrets as well as short-term secrets. Okay. So that is one of the design has been taken care of that, so that session key security will be provided based on the Sikhi adversary model. So then that we have done something practical perspective with respect to the Ns2 simulations. So network was simulated, for example, 1800 per seconds, 30 minutes durations. We have taken the 3 scenarios here. In the first scenario, it consists of the 10 users on mobile device, 10 service provider, smart meters. So all the scenarios we have taken the 10 smart device or service providers, but we have varies the number of users on mobile devices. So, so then we have compared with the existing state of solutions here. For example, Sai and Lo, Odelu, one of our earlier paper, Joe et al., then Wu and Joe, Sia and Wen. So then we have used the Ubuntu in that time, Ubuntu 14.04 LTSY there at the latest platform. Then we took the network coverage area, number of smart meter, mobile users. And also we have considered the mobility of the users. For example, if it is 2 meters per second, that user is, say, for example, walking in a garden, 10 meters per second or 15 meters per second means user, say, for example, driving a vehicle with the speeds and etc. So then we have taken all these things. We have measured the throughput, end-to-end delay, as well as packet delivery ratio. Then we compared with the existing protocol that we have seen that our scheme reasonably performs well as compared to the other protocols in this case. So then that this is one of the case study of the smart grid environment. Then what I'll do that I'll just briefly touch that can we enhance the security of the smart meter, smart grid environment with the help of that blockchain technology. Just I'm going for a little descriptions here. So with only the 5 or 10 minutes, then I'll close this session here. So if you look at the blockchain, so blockchain is one of the very new technology, and it can enhance the security of the system. And blockchain is treated as the linked list type of things. But in the linked list, that once your informations are stored in the nodes, the nodes can be deleted, updated, or you can update the informations in the nodes. But in case of the blockchain, so the block consists of the digital informations where you are linking on all the blocks in a chain in the forms of linked list. But once your block is inserted in a blockchain by means of some protocol known as the consensus mechanisms protocol, that block cannot be deleted, modified, even you cannot update any informations inside the block. So that's why that one of the thing is that blockchain is treated as the decentralized, because each and every block is stored distributively in several nodes, so that even a server, say, goes down or node goes down, other nodes will be there to take care of the service to the customers. The data is cryptographically stored inside. If your data is secret, the data is encrypted and forms in the stored in the blocks. If your data is not even encrypted, the previous block has, as well as your marklet wrote and as well as your signature on the block, that will give the cryptographic security. And blockchain is non-immutable because nobody can tamper with the data once the block is there inside the block. And it is also transparent because anyone can track your data. For example, you put some block in the blockchains, later that you can always verify whether your block has been put correctly or not. So that kind of transparency is provided in the blockchain also. So therefore, we are having the 3 pillars in the blockchain technologies. One is known as the decentralizations, another known as the transparency, another known as the immutability. And there is a cryptographic hash functions as a cryptographic tools that is very important to provide the immutability. So for example, say the hash function is very sensitive to small perturbations in the inputs. That means that even a single bit or some bits of the input message has been changed or modified, that will produce a completely random and unique hash value. And that will be used to detect whether your data has been changed or modified or not. So for this purpose, for example, if you are having the input, say this is a test, so your hash output is like that. If you say simply change uppercase T to lowercase t, this is a test, that will give or produce a distinct that random output, and it's like this. Okay. So this is immutability property is achieved by means of utilizing one-way cryptographic hash functions. And also that I'm not going to details here. So blockchain is maintained by a peer-to-peer networks where each and every node in the blockchain can communicate with each other. And most importantly, that each and every node is given the equal privilege, means that the entire workload of the systems is equally distributed. That's why they are equally privileged. They are known as the peers. And hence, in this case, there is no central servers. There are several distributed and decentralized peers. They can communicate each other. So the based on the type of applications, you can have the permissionless blockchain, where that anyone has the right to join, access, send, verify, receive transactions on the block in the blockchain to create consensus. One of the mechanism is then known as the Bitcoin or blockchains, Bitcoin or cryptocurrency. So private the blockchain where the owner of the networks decide which nodes to assign the rights to send, access, receive, join, verify the blocks. For example, the healthcare applications where the patient-related information are very private and confidential. So therefore, in that kind of scenario, private blockchain is more useful for military applications also. So there are certain applications where consortium or hybrid blockchain is necessary. Most of the information is public and some of the information are confidential. For example, internet or vehicle applications where intelligent transportation systems is there. If there is a very high profile accident is there, that kind of data is put in the private, otherwise all that most of the data are public. So adding a block consisting of the informations that block needs to be that inserted in the blockchains, that is done by a consensus mechanisms or agreement protocol. So there are several agreement protocols are there. Probably that will be covered by some of the experts here. So for example, you can have the practical Byzantine fault tolerance algorithms. So this fault tolerance algorithms works as follows. Suppose in a peer-to-peer networks, a leader will be first selected. The leader will first send the block addition request message to all the peer nodes in the networks with the block to be added. Then the block will be verified by each and every peer nodes in the networks. And they will verify the block, and once the block is verified, they will reply the valid reply message to the leader. The leader will make a counter R count, and when the R count exceeds a threshold below 2NF plus 1, where NF is the number of faulty nodes or malicious nodes in the peer-to-peer networks. So that means that when the 2/3 of the nodes will give the same valid reply message to the leader, the leader will confirm that this message is, this block will be added in the blockchain. So then the leader will add the block in its local ledgers, as well as it will send a that is known as the commit message to all other peer nodes in the network, so that all other peer nodes can add that block in their local blockchains. So this is one of the same mechanism is used here. So for example, in case of the Bitcoin, suppose Alice wants to send some dollar or say money to Bob. So Alice then will create a transactions in forms of Bitcoin. Then Bitcoin will be mined in a blockchain networks, peer-to-peer networks. So using a consensus mechanism, for example, that is a protocol known as the proof of work protocol that will allow whether this transaction is valid or not. If once the transaction is validated, then the transactions will be entered to a block in the blockchain. So in that way, the transactions will be declared as the complete. So later that Alice as well as Bob they can view that whether all the transactions are correctly put or not, and anyone can verify and can see what kind of transactions that Alice has basically done with the Bob. So then that in this case that what we are having that due to several restrictions from the government as well as other countries, Bitcoin or cryptocurrency, they are not so popular. So therefore, researchers found that there are several civil applications of the blockchain technologies. For example, it could be either in the smart manufacturing, supply chain, food industry, Internet of Vehicles, or Internet of Domains environment. It can be applied to the smart, that is the healthcare applications. It can be applied to the smart grid environment. So that's why there is a new concept came, something known as the Internet of Things, like that we are having the blockchain of things, BYT. So which is giving the several civilian applications, military applications, and so many other applications where the blockchain will be a potential candidate for applying in the security part. So just I'll give 1-2 slides here. So how that blockchain-based smart grid security can be achieved here. So in the blockchain distributions in blockchain networks, suppose that we are having all the nodes. We are having 4 nodes. 4 nodes are treated as the something known as the service providers. Service providers are attached to the several smart meters. Smart meters, service provider, they will communicate with several messages. They will form some transactions. Those transactions will be put in a block. Suppose that there is a new block is there, that block needs to be added in the say peer-to-peer smart grid environment. So then what will do that, say node A being a leader, that will broadcast the new blocks to each and every nodes in the network. So then it will run a consensus mechanisms or agreement protocol, for example, the practical Byzantine portals algorithms that will validate whether this block is genuine or not. Then only that block will be basically added in the blockchain. So respective the local ledgers of each and every node that is blockchain. So in this direction, so if you look at here, 2 types of things. One is known as the centralized things, another known as the decentralized things or distributed things in case of blockchain and non-blockchain parts. So in case of the non-blockchain, we are having a trusted the party, and the trusted party is registering that service providers, then service provider, under service provider we are having service that is smart meters, then other things are there. So there we are having something, so many mechanisms are there. One is known as the registration mechanisms, another known as the authentications, by which that service provider as well as smart meter can authenticate each other, they can securely communicate each other, all these things. Okay. But in case of the blockchain technologies, so we are having something known as the signature device infrastructure that will allow basically the key encryptions, and we also require the authentications between the service provider and smart meter so that secure communication should take place among them. So once that service provider has all the informations known as the transactions from service smart meters, all these things, then the transactions will form block, and that block will be mined in a service provider peer-to-peer networks using consensus algorithms. Then that block will be added in the this is the blockchain networks. So this is the way that smart grid environment blockchain technologies can be supplied. Here is that even one service provider is down, so other service providers will be there to take care of the services. But in this case, since it is based on the centralized things, so attacker can target that TTP, and it will be a single point failure of scenario in case of the centralized things. So for further reading, so you can have a recent work on designing a blockchain-based access control in IIT-based smart grid environment that was published with my research team here, along with Professor Vasikulas from Sweden, collaborator. So that was published in IEEE Internet of Things journals. So apart from that, you are having also some of the other good references. For example, blockchain-based decentralized and secure keyless signature scheme for smart grid environment, and blockchain applications in smart grid Rivian framework, which is the very good survey paper for starting point of view, which will talk about that smart grid applications and how the blockchains can be applied and what are the benefits we can get, and which was available in the IEEE access from 2019 paper. So okay, so I think that I have talked much, and let me to take questions, several questions once we have, because we are running time. Okay.
So thank you, sir. Thank you for this lecture. So we request the participants to please post their questions regarding this lecture in the chat section, either in the chat section or Q&A section. Sir is available so that he can answer. Some of the participants have also raised their hands. So
Yeah. Please ask. Yeah.
Yeah, I'm unmuting. I'm trying to unmute them.
Yeah. Yes. Sure.
Yeah, Chintana Patel, ma'am, I have Chintan Patel, I have unmuted you.
Yeah, so please tell you.
Good afternoon, sir.
Hello.
Yeah.
So basically, you have said that you have done the simulation in the NS2.
Yeah,
How
yeah.
we can simulate the biometric fuzzy sector and that all the things in the NS2?
Yeah. No. For NH2 things that we have only done the communications part, okay? So we have prior to that, say we assume that already the authentications login page already done. But
Okay,
only the what thing is we have done that, say message communications which are taking place, say for example, during login authentic login page, the what message is going to which entity, and authentication key agreement page, which message are going to which party. On the communications part, we have done it, that one. Okay.
okay.
Or
And
again, that what question is that if you want to do your biometric local authentication everything, we have not done exactly on this problem, but we have done test bed simulations here in our lab here with the help of IoT devices. For example, you can install the Raspberry Pi on the smart gate the device. Then you can connect with smart gate device with the desktop. You can implement the whole protocol, including fuzzy extractor, everything. So that is possible.
okay. And sir, second question was that which smart card actually we can use for real-time demo? Like for example, I want to use the Raspberry Pi at both the side, and
Yeah.
I want to do the smart card computation also,
Yeah.
where I want to store some basic parameters.
Yeah. So
So
there
which
are
hardware smart card we can use? Is there any option?
no. There are several smart cards are there in the market. So any one of the things that we can use. Okay. For example, that in this case that we used basically the mobile device. Okay. So instead of the smart card, we have used the mobile devices. It is also possible to use your smart device, smart card device also, smart card also. So for example, you have your smart mobile device. In mobile device, we store all the informations. Okay. So otherwise that you can have your smart card. Smart card, there are several good smart cards companies are there. So here you can take it there. You can store your all the informations. The smart card will be able to do the computations. Or in other words, that if you connect with the Raspberry Pi and if you store all the information, so Raspberry Pi can also compute on behalf of the smart card here.
So thank you, Chintan Patel, for raising this query. So with this, we come to an end to this session, sir. So on
Yeah.
behalf of the Principal Coordinator, Professor Ratnajit Bhattacharjee, sir, from IIT Guwahati, and also on behalf of the Joint Principal Coordinator from IITDM Jabalpur, Dr. Neelam Dayal, ma'am, I express our thanks to our expert, Dr. Ashok Kumar Das, sir, for accepting our invitation and coming on board to share his knowledge on this topic of smart grid and IoT, sir. Thank you. Thank you so much.
Yeah, thank you very much. Okay. Thank you.
Thank you. So dear
Yeah.
participants, so with this we come to an end to this lecture 15. So shortly after 10 minutes of break, we will start with our hands-on session 1. So hands-on session 1 will start from 12:30 onwards. So we request all the participants to please have a break and come back by 12:30.
Yeah. Okay. Thank you.
Thank you, sir. Thank you, sir. Thank you for joining, sir.
Okay.
You may disconnect now.
Yeah. Okay.
Thank you. Hello. Yeah, Jitesh, sir, are you there?
Good afternoon, ma'am. Yes, sir.
Yeah, good afternoon, sir. So I'm making you the presenter in this platform.
Okay.
Please give me a second. Okay, so Jitesh, sir, you are the presenter, yes?
So, can you visible, ma'am?
Yes, sir, the screen is absolutely visible. So we will be starting our next section, next lecture by 12:30.
Okay, okay, ma'am.
Okay, thank you. So dear participants, good afternoon all and welcome back in this next session of this day 2 of online faculty development program on Internet of Things and applications. So now it's 12:30 already. So we will start with our hands-on session 1, which will be conducted by the IoT Academy. So the first session will be taken by Mr. Jitesh Kumar sir from IoT Academy. So before we start with the session, we will have a short introduction about our next speaker. So Mr. Jitesh Kumar sir is senior IoT engineer in the IoT Academy. He is qualified and experienced trainer with 7 years experience in IoT, wireless and embedded industries. He has trained more than 1,200 students till date, and he has also trained students and faculties in association with IIT Guwahati, IIT Kanpur, and many other engineering colleges. He is BTech in Electronics and Communication Engineering from Gyan Vihar School of Engineering and Technology. His areas of interest mainly include embedded systems, Internet of Things application, cloud computing, etc. He has various programming skills in embedded C, RTOS, Python, data structures in C. He has IoT related hardware experience on Uno hardware, Arduino Uno hardware, Node MCU, and Raspberry Pi. He has also experience in developing IoT protocols like HTTP, MQTT, COAP, AMQP, etc. So with this short introduction, I would like to request Mr. Jitesh Kumar sir to please carry on with the hands-on session 1.
Thank you, ma'am. So am I audible?
Yes, sir, you're audible, absolutely audible.
Okay. So good afternoon, everyone. This is our answer number 1. That is the object classification on Raspberry Pi. So in this hands-on, we will do the live classification of the object using Raspberry Pi. So these are the steps for the hands-on that we have to cover. So the first, that's the Raspberry Pi OS installation. The second is the Edge Impulse account creation. The Edge Impulse installation on Raspberry Pi. The fourth one, we deploy the machine learning model on Raspberry Pi, and then we run the model. So we train the model on the Edge Impulse. So Edge Impulse is for, we have to create the account on the Edge Impulse. We train our model on the Edge Impulse, then we deploy our model on the Raspberry Pi. So for this, you have to install the Raspberry Pi OS on your Raspberry Pi. So for this, you need 2 software. That is the PuTTY software you need, and the second is the BNC viewer. These 2 software you require. So I think you will get this PDF yesterday. So how to install Raspberry Pi OS? So these are the hardware required in the market. There are 2. You will get the Raspberry Pi 3 or Raspberry Pi 4. There is a huge difference between it. There is in the Raspberry Pi 4 there are 2 HDMI micro HDMI port. There is only single HDMI port. It is powered by USB Power C. It is powered by USB Type B, and there is a RAM is separately there. The price of RAM is 2 GB, 4 GB, and 8 GB model in market. It is available, and there is some powerful processor. So you can use any one. Maybe you can use Raspberry Pi 3, or you can also use the Raspberry Pi 4. And you need a micro SD card, minimum 16 GB, and it should be class 10 because the speed of the class 10 is very fast. So it will help you to upload the Raspberry Pi OS quickly onto the card. Otherwise, it will take some time. Then you need a memory card reader because you have to plug the memory card into this memory card reader. Then you have to you have to plug into the USB of the laptop. And you need a power supply. So for Raspberry Pi 3, you can use micro USB cable. And for Raspberry Pi 4, you have to use the USB Type C cable. So you can use also your mobile charger also to power up this Raspberry Pi. So, and this is the last component that you need, that is the Raspberry Pi camera. You need this camera. So have you installed the Raspberry Pi OS? Please write into the chat option. Have you installed the Raspberry Pi OS and have you successfully connected with the Wi-Fi? Please reply into the chat. Have you installed successfully the Raspberry Pi OS? Okay. So I am repeating the steps here. Please follow the steps. If you don't have the Raspberry Pi, you can watch, you can see this experiment. If you have the Raspberry Pi, please install the Raspberry Pi OS. So see, these are the steps I am repeating. You have to write the Raspberry Pi, and there is a website is raspberrypi.org. So here you will get the information now. Here is the this is the for the Raspberry Pi Foundation. Different Raspberry Pi modules are there. So you have to now visit the raspberrypi.com. So you have to click on visit raspberrypi.com. Then you have to click on the software on this website. You have to click on the software. This is the official website from the Raspberry Pi. I am also showing you here. This is the official website from the raspberrypi.org. It is not a third-party website. And here you have to click on visit raspberrypi.com. So this is the raspberrypi.com. So now here you have to click on the software. So you need a imager. So Raspberry Pi imager is the Sikhi. So see here, when you click on the software, you have to download. This is the Raspberry Pi OS. So Raspberry Pi needs an operating system to work. So that is Raspberry Pi OS. Previously, it is called the Raspbian. That is the official operating system for Raspberry Pi. So similarly, so Raspberry Pi, you need a monitor, you need a keyboard, you need a mouse, and you need a, this is the Raspberry Pi. So how to install OS on memory card? That is the SD card. So Raspberry, you need a software. That is the Raspberry Pi Imager. The name of the software is the quickest and easiest way to install Raspberry Pi OS and another operating system to micro SD card, ready to use with your Raspberry Pi. So there is also the 45-second video. You can also use this. So and also I am also already given that. So you have to click on the download for Windows. And for another operating system, these are the steps. Download for Mac OS, download for Ubuntu, and you can click according to your operating system. So right now I'm telling here the download for Windows. So maximum users are using Windows operating system. So just click on the download for Windows. Then you have to click the imager file. The imager underscore 1.7.1. You have to save this file. So you will get a imager file. Now, when you click, you have to install this. So just double click over there. Simply by simple next, you will click on the install, then click on the finish. Now the imager is successfully installed on your laptop. So that is the imager, Raspberry Pi imager. So you can also, when you successfully install, so see here, you can write here Raspberry Pi imager. This is the Raspberry Pi imager. That is the software which you are showing here right now. This is the Raspberry Pi image. Is it clear, everyone? It is clear, everyone? Yes or no? Are you getting, everyone? Are you getting, everyone? Please reply into the chat option. Okay. So now you have to click on the choose OS. So when you click on the choose OS, there are a lot of options. So we are using right now the default recommended from the Raspberry Pi OS, that is the 32-bit. This is the by default we can say the operating system. So we will select this Raspberry Pi OS. Previously it is called Raspbian. So this is Raspberry Pi OS 32-bit. Select this OS. Now put your memory card into the card reader and connect the card reader with the USB port. So you have to put memory card into the card reader. That memory card reader you have to plug onto the USB port of your laptop. Now when you click on the choose storage, so here you have to select that memory card. Please carefully don't select any drive, C drive, D drive, E drive. Select proper drive. That is a memory card. It is which is visible onto the mouse. So this is in right now in picture it is showing. This is in my case is an 8 GB memory card. So it will show you the capacity of the memory card. So don't yes. The imager. So please check where you download. Where is you download, ma'am? Dr. Garima Bhadwar, ma'am. Please check where the imager you downloaded from the browser. So check from the browser download, or if you are using another downloader, so check the where your downloader put the final file. That is the any other option. If you do, no, ma'am, there is no other option. We need memory card or Raspberry Pi also. There is no other option. How can it is possible without memory card? How can it is possible without hard disk? If in the laptop, if there is no hard disk, how can you run the operating system? Similarly, if there is no memory card, how can it possible you run the Raspberry Pi? There is no option. For IoT, you need hardware. Please remember, everyone, it is compulsory for IoT. You need hardware. There is no simulator in the market who provide you the complete solution. So yes, in this experiment, you can use the phone, your mobile phone, but you cannot do the live classification because we run the model onto the Raspberry Pi. We deploy our machine learning model onto Raspberry Pi. So you can use mobile for little bit, not for the complete experiment. So now, if you have the hardware, you need memory card, and you had the file already. It is already shared. What are the hardware requirements? See here. This is the hardware required. Raspberry Pi 3 or 4. You need memory card. It is compulsory. And you need memory card reader. You need power supply. You need Raspberry Pi camera. These are the hardware. Now select the imager. That's finished. Now choose the storage. So storage is your memory card. Please carefully select this storage and then click on the right. And then anything that is into the memory card, if you have already some files, that will destroy, that will delete it, that will be erased. So then click on the yes. Now this process will take approx 10 to 15 minutes. It depends on the type of the class. What is the class? If you have class 10 micro SD card, it will take only 5 minutes or 7 minutes. If you have the lower class, then it will take some time. Now the importance of the class 10 will encountered here. So it will see this in the PPT is already shows. First it will show the writing 0%, then slowly it will show writing 15, then writing 25 like this. Then it will verify. Please wait. Let it verify. After verification, now it will give you a message. The Raspberry Pi OS has been written to your storage device memory card. So this process will take 10 to 15 minutes if you have a class 10 memory card. If you have a class 2, class 3 memory card, it will take a lot of time, approx half hour or 1 hour. Depends. That is the importance of micro SD card. Is it clear to everyone? So now, now the memory card is successfully there is a Raspberry Pi OS. Now, when you again, now after this process, remove the memory card reader, and again connect to the laptop. So it will show you this type of drive name, boot, the last drive you will get. So this CDEF drive, this is my laptop drive. And the last drive, that is the approximately showing, this is the boot drive. The name of the drive is boot. So now what to do? We have to connect. Now the process is coming. How to connect the Raspberry Pi with the Wi-Fi? This process is coming on now. Please everyone, because if you have Raspberry Pi, then after this process you have to connect with the, you have to put the memory card into the Raspberry Pi and power it on. But how to connect with the internet if you don't have any other extra monitor? See here, if you and you wanna see Raspberry Pi GUI on your laptop. So you have to connect with the internet. So this is the process. Please everyone focus on this. So you have to open this drive. This drive already written. Double click on it. Now you have to create file. The file name is wpa_supplicant.conf. Please write the name. This is, see here, it is already showing here. Please create a text file and change the name wpa_supplicant.conf. Okay, I am showing you again how to create a file like this. The right click, just go to new and select the your text file. This is the text, and change here. Name is wpa_supplicant remove.txt and con. This file you have to create into this boot drive. Please everyone, please, we have to make this on the boot drive. So this is the wpa_supplicant. This is the name you will get here in big font. wpa_supplicant.con. That's why we already shared this file with you before one day. wpa_supplicant. Now you have to write into something into this file. So just right click on wpa_supplicant.conf and click on open with. Now select the notepad from the, you will also click on the more app, then you will get the notepad. So now this text you have to copy. So this text is, I will give you this text. See here. This is the text. This is the text you need. Country, you don't change. Just only write your Wi-Fi SSID, means your Wi-Fi name and your password. Right now, and from which Wi-Fi you want to connect your Raspberry Pi, you have to write accurate Wi-Fi password. Please be careful about capital letter and small case letter. Be sure. So you have to write accurate Wi-Fi SSID and you have to write accurate Wi-Fi password here. So this file I am sharing with you. Just give me 1 minute. So ma'am, can I share the file? Hello. Just give me 1 minute. Just give me 1 minute.
Dear participants, there is one announcement from our end. So the drive is been updated with day 1 contains. The attendance sheet will be shared by today end of the day. Thank you.
Hello, ma'am.
Yes, sir. Yes, sir.
Ma'am, I shared 2 files to you. Please share them with the participant. I am unable to share from here. Is there any option I can share from here? Any file?
No, sir. From there it can't be done. Okay, I'm sharing it in the drive. Yeah.
Yes, yes. I shared the 2 files to you. Please share these files with the participant.
Okay, sir.
I
Please
shared
give me.
a file. Yes, ma'am.
Yeah, please give me 10 minutes. I will share it.
Yes, yes, ma'am. So this is the content you have to say, you have to copy into that file. So I am repeating again. Just double click on the boot file, and here is the W. You have to create a file WPA underscore supplicant.conf. Please, every character is in a small case. WPA underscore supplicant.conf. Then click on the yes. Then open this file with the notepad, and now this is the content. So this content you will get. So ma'am will share you this content. So this is the country. This is a, don't change anything, just change only. You have to write your Wi-Fi SSID, means your Wi-Fi name, and proper your password. Like right now, I am also written already. This is my Wi-Fi name and password. Then save it. Now again, next step. In same, next step is just right click, then click on the new, same, click on the text document, then create a file. The name of the file is SSL, and remove .txt extension. Only the name is SSH in the small case letter, and then click on the yes. Okay, so see here in the red color box, the SSH file is created. See here the SSH file. So you need to create 2 files. I am repeating again. Just double click on this. One file is WPA underscore supplicant.conf. You have to paste this content. In content, you have to change 2 things: your Wi-Fi SSID and your Wi-Fi password. Then you have to create the SSH file and remove the like here. Click on new text document. Then remove the .txt extension and SSH file. Now you have to put memory card into the slot of Raspberry Pi. See here, you have to put memory card. There is a slot in back side. You have to put the memory card and power on your Raspberry Pi. So now, when you power up your Raspberry Pi, so after 1 or 2 minutes, so there is a software you need for this. The software is Angry IP Scanner. You need a IP scanner app in your laptop. You can download from the Google also. The app is Angry IP Scanner. Angry the IP Scanner. This is the app. So you have to download this app for Windows or any with your requirement. I am sharing the link with you. This is the link for the Angry IP Scanner. So when you open this Angry IP Scanner app, so you have to write the IP range. So IP range is like what is your IP? Like right now, if you open the command prompt, in my case right now, see here CMD, my case, and I am checking the IP of my local IP. So see here the local IP is this 192.168.29.36. This is my IP, my laptop IP, and this is my router IP. This is the default gateway IP. So we need this 192.168.29. So we will write here in the Angry IP Scanner 192.168.29.02. same 255. The remaining content is same 192.168.29. And when we click on the start. So see here right now I am also showing here. This is the Angry IP scanner. So it will automatically see here 192.168.29.02255 and we click on the start. So it will show you the list of the devices that are connected to your router. So see here, now I will get the IP of my Raspberry Pi. See here, 192.168.29.27. This is the IP of my router, my Raspberry Pi. See here, 47. Because in the file I written the SSID and password. Okay. So that is the step. The Angry IP scanner, that is a very famous software. So now you need putty software because you will work on to the Raspberry Pi from the command line from the terminal. So you need a putty software. So the link of the putty, you can also in the Google, if you write on the putty software, you will get the link. I already given the link. This is the putty software. Download putty software. So this is the putty software for the Windows. So you have to click on. You can download putty from here. Then you can download. Now, so the same IP. In my case, see here in this PPT, the IP of the Raspberry Pi is this 192.168.18.223. Similarly, you will get a IP, Raspberry Pi IP. So now put that IP into the putty software, then click on the open, then click on the yes. It will ask from the login ID and password. So login ID is PI and password is Raspberry Pi is already written into the slide. So now you will get the terminal of the Raspberry Pi. Though you are not getting the GUI, you are getting the terminal. So here you have to write a command. The command is sudo resp config. Sudo resp config. You have to change the configuration. So here in this you have to select the interface option. Then click on the VNC. So click on the VNC and you cannot use here the mouse. You have to use the keyboard up and down key. So just select this VNC and enable it. Similarly, you have to enable the camera also. So this is under the interface option. So when you check in the interface option, it will show you I1, I2, I3, I4 like this. When you check on the performance option, it will give you P1, P2, P3, localization option L1, L2, L3. So you have to go into the interface option and here you have to enable and disable graphical remote access using real VNC. So this is the VNC where you have to enable. Then you have to click on yes, then click on the OK, then click on the finish. Now you have to reboot your Raspberry Pi. When you reboot it, now you need a VNC viewer. That is for the graphical display, remote graphical display of your Raspberry Pi. So how to download VNC viewer? The same process. You can write onto the Google and the link is already written into the file. Okay. So you need a VNC viewer. This is the VNC viewer. You can download from here. So this is the VNC viewer. This is the link. So you can download from Windows, just download VNC viewer. Okay. So now similarly, so now you have to write the IP of your Raspberry Pi that you will get. You go onto the Angry IP scanner. Like in my case, when I created this screenshot screenshot when I created this PDF. This that time the IP is 192.168.18.223. Same IP you have to write into VNCVR. When you write the same IP, click on the continue, so you will get the GUI of Raspberry Pi. Then click on the next, select the country, language English, the time zone Kolkata, and click on the next. Now, see here, I am also already, this is my Raspberry Pi right now, and I will get this this GUI, and this is the terminal. This is the terminal, and this is the GUI. So this is the whole process of Raspberry Pi OS installation. So is there any confusion in Raspberry Pi OS installation? Now tell me. These are the steps. In any step, this is the part number 1, how to install Raspberry Pi OS. Repeat once. We cannot repeat the whole step. Please tell me where you are getting issue. Please tell. We will share this PPT, and also we will share the video. There is a live streaming video. You can also watch. Yes, yes, we will share. We will share the slides of all the steps. Yes, we already shared into the Telegram group. After memory card preparation. Yes, I am repeating on memory card preparation. Okay. So this one, when you prepare the memory card, so now, sir, you are getting, hello. So double click on the boot file and create a file. The file is wpa_supplicant.conf. You create a text file and write the name and extension in .conf. WPA_supplicant. It should be small case letter. Then open with file this notepad and the content of this file, because this file already blank. So you have to paste this content. This content you will get from the Google Drive, or the file is already shared. So, but remember, you have to change your Wi-Fi SSID and password. You have to change your, you have to write your Wi-Fi SSID and Wi-Fi password. Now again, and you have to save the file. After this, just save the file. Now again, create a file. The name of the file is SSS, and there is no extension. Just remove the remove the .txt extension. And now remove the memory card from the card reader, put it into the Raspberry Pi. Then from Angry, just power out the Raspberry Pi. Wait 1 or 2 minutes. In Angry IP Scanner, or you can also download any app in the mobile store. There is a network IP Scanner app. You can. So now scan the IP. You will get a IP. Put the IP into the putty. Enable the VNC. Then reboot. Then write same. Now after starting the after rebooting. Now start the Raspberry Pi again. It automatically started after 1 or 2 minutes. Now write the same IP and you will get the GUI of the this Raspberry Pi. Is it clear? Install, yes, hi sir, we installed OS. So what was the use of hardware? Hardware is there and you are getting the remote GUI on your laptop. Now we will do the experiment. Hardware uses we will then up in in this experiment, we will run the edge impulse. We will deploy the machine learning model onto the Raspberry Pi. That is the need of the hardware. Yes, for me, Chitrapu, ma'am also, I don't know what is. Hello. Yes, are you getting the use of the hardware? Because we have to deploy it. So we are getting the GUI as a remote location. Okay. So now this is the step number 1. I already discussed this is the step number 1. The Raspberry Pi OS installation. Now the second step, Edge Impulse account creation. You have to make the account on Edge Impulse. Everyone, please. So please, everyone, this is the second step of the Edge Impulse account creation. Everyone, please see here. So now, open the Edge Impulse website. How to open it? Open the Google and write Edge Impulse and open this website www.edgeimpulse.com. I am also doing with you. Please, everyone, do this. Open the Google. This Raspberry Pi work is completed. So open the Google. Everyone, do quickly. This is the Edge Impulse, and this is the website www.edgeimpulse.com. So I am sending this link to. So what is Edge Impulse? This is the Edge Impulse. This is actually the development platform for machine learning on the edge devices. When we want to deploy our machine learning model on the edge devices, so we can use the. So there is a vibration anomaly we can discuss. See here when you this is the package, and see here this is the raw data we will get, and so we will use this. So everyone, the link is already shared. Now open this website, then click on the get started. Everyone, do quickly. Just click on the get started. Now write here you have to fill the details. Everyone, please fill the details. Please fill the details. So here you have what should be. So you can write your name. You can write a username, email ID. And please remember the password. Please put the password as simple because we need this password. Please remember the password. Don't put anything. Just put the password as simple. Okay. And please remember the password and also the email ID. So please use also the Gmail ID if it is then you can easily do. Please use the Gmail ID and click on the then I accept the privacy. Then click on the sign up. So now after the sign up is successful, now click here to build your first machine learning model. Just click on this. Click here on this first machine learning model. Then there is a welcome. You are only few minutes away of making your device feel here and see the real world using machine learning. So just cross this prompt, this pop-up window. So are you able to make the account of Edge Impulse, everyone? Have you created the account of Edge Impulse, everyone? Okay, now follow the steps. Everyone, quickly. So now, here on the right hand side, you will get your name. That is your username. And now click on the create new project. just click on the create new project, and here you have to write the name of your project, that is the image classification. Please write the name of your project, image classification, and you can write any name, no issue, but our target is image classification. That's why I am writing the relevant name. So image classification, then click on the create new project. So now close this pop-up window. Now close this pop-up. So now please tell me, are you able to create the new project? Yes or no? Please write quickly. Are you able to create the new project? I am repeating again. See here. Please do quickly because we have to cover a lot of things. So now open the Edge Impulse website, www.edgeimpulse. Then click on the Get Started. Now you have to fill the details and click on Sign Up. You have to fill the details. What should we call you? You can write your name. Pick a username. Similarly, you can write your name, your email ID, and your password. Which password you want to set here? So put the simple password. Then click on the Sign Up. Now, after sign up successfully, you will get this type of web page. Sign up successful. This is the thanks. This is my username. And so similarly, you will get your username. Now click here to build your first ML model. When you click here, now it will give you a welcome pop-up window. Just close this welcome pop-up window. Now you have to create a new project. So just here on the right hand side, you will red rectangular boxes are giving you navigation. Okay. In my PPT, the red boxes will give you the navigation. First, click on your username. That is in your account is your username on the right hand side. Then click on the create new project. So now, Edge Impulse is a freeware, free. So create a new project, image classification. Then click on create new project. It is a free platform for machine learning model for the edge devices. Now close this. So this is the pop-up window you will get. So now tell me, are you able to create the project and the account on the Edge Impulse? Now, have you created the project and you have created the account on Edge Impulse and successfully created the project, the image classification? The last step, okay, so the last step is nothing. You have to write the project name. See here on the right hand side, then create new project. So there is a image classification. You have to write the project name, then click on the create new project. Then you have to close this pop-up window. Now we will collect some data. So we can also collect data from our mobile phone. We can collect data from any edge device, any hardware. So now everyone, please click on let's collect some data. Everyone, please click on let's collect some data. Then click on show QR code. Then click on show QR code. So now you will get a QR code like this. You will get a QR code like this. So please scan this QR code with Google Lens app. If you have in your mobile, if you have an app, that app is a Google Lens. So please install the Google Lens app, Google Lens, Lens, and scan this QR code with Google Lens app. So when you scan, please everyone install the Google Lens app. You have to scan your QR code, not my QR code. So do you? Yes. So click on the create new project, write the name of the project, then click on new project, click on create new project. Now close this pop-up window, just close it. The red rectangular boxes will give you what to do. Please focus on the slide on the red boxes, red rectangular box. Now click on, now you will get this type of web page. Now it is showing 0 device connected. So we have to connect Raspberry Pi and we have to connect our mobile phone. So just click on let's collect some data. And here is the, now for data collection, we have to connect a device. So we can connect a development board, we can use our mobile phone, you can use your computer, anything. So right now we are using our mobile phone for data collection. Your mobile phone, Android mobile phone, any. So there is a QR code you have to. So just click on show QR code. So this is this type of QR code you will get. So just scan your QR code, not mine, please everyone. Scan your QR code with the Google Lens app. So in the mobile, see here, in mobile, you will get a link over the QR code. Just click on this link in mobile. So it will show you. Now Edge Impulse will show you your device phone. This is now connected. So your mobile phone is now connected with Edge Impulse. Are you getting everyone? Are you getting everyone? Yes or no? So now this is the second step. When now you successfully connected the mobile with the Edge Impulse. This is the second step of the project. This one, Edge Impulse account creation, and you successfully connected the mobile with the Edge Impulse for the data acquisition. Now just wait. Now the third step, we have to move on the third step. The third step is Edge Impulse installation on Raspberry Pi. The Edge Impulse we have to use onto the Raspberry Pi. So for this, I shared a Word file. Everyone, I shared a Word file. Please download that Word file and open it. Everyone, I shared a Word file like this. Please, everyone, you can download a Word file. The ma'am is already shared. So please check. There is a Word file. So this is the steps of installation of Edge Impulse on Raspberry Pi. So you will get a file. Are you getting this file? Please everyone, this type of Word file which we are showing onto the screen. Have you got that file? Please open it. Everyone. Please open it quickly. Have you got? Please acknowledge. Have you got? Okay. Now the third step is installation of Edge Impulse on Raspberry Pi. This is our third step. Edge Impulse installation on Raspberry Pi. So everyone, if you have right now Raspberry Pi, if you have the Raspberry Pi, so open the terminal and open the terminal. How to get this terminal? Just this by pressing this button, this black color terminal. So open the terminal and write here sudo apt/get update. Please write this command sudo apt/get update and press enter. Sudo apt/get update. Please write this. And please connect the camera also with the Raspberry Pi. Please connect the camera also with the Raspberry Pi. Please connect the camera also with the Raspberry Pi. So, how many participants do you have Raspberry Pi with you right now? Please acknowledge it. Please write into the chat if you have Raspberry Pi right now. Remaining participants, please write into the chat if you have right now the Raspberry Pi. Okay. So, Dr. Sunirna Jadhav, ma'am, please write this first command sudo apt/get update. Only one participant. Okay, you have okay. You have Raspberry Pi but not camera. So, do you have the webcam? Akhil Arora, sir, do you have the webcam? Okay. You can do also with the webcam. No, if you have, you can arrange within 10 minutes. If you have webcam. So the list is already shared. The hardware list is already shared. You need camera, you need, because the image classification for image, you need a camera. So this is the first command. You have to write sudo apt/get update. So have you written? Please do this, everyone. If you have Raspberry Pi, please do this step. So Dr. Sunanya Jadhav, have you done this? And Akhil Arora sir, have you done this step? Sudo apt/get update. Okay. Now sir, now please do quickly, do slowly, because now you have to do. So now the first step is first command is sudo apt/get update. This is the first command you have to write onto the terminal. Now second command. So this is the second command you will get from the Word file. The first one in the red one. So please see here. This is the command that written into a red color. Are you getting everyone? So just copy this first command. Copy this first command and paste into the Raspberry Pi terminal. Just right click that, paste into the Raspberry. This is the first command and press enter. So now it will download some packages. Please everyone do this. See here. the first step is completed. The first command, the first one is sudo apt get update. Then after this command. So this command you will get from the Word file. This is in the red color. See here. Just copy this and paste it into the Raspberry Pi terminal, and this is. So have you run this command? Ma'am, the Word file. So please, anyone, please share this Word file. I will share this Word file into the Telegram group.
Hello. The Word file is also shared in the Telegram group also. Okay. So we request all the participants to have a clear look on the Telegram group. The two files which were shared by the expert is being shared in the Telegram group at 12:58 p.m.
So yes. So this is the first one. So Akhil Arora sir, have you run this first command? So now the second command, see here. So this is the first command, curl -sl http node source. The second command, now after first command, the terminal will look like this. Now this is the second command. So second command you will get from this one. This is the second command. This is the second command, and paste into the Raspberry Pi terminal. This is the second command, and press enter. So now it will take some time to download. It will depend on your internet speed. So you need a good internet speed. Please, this is the second command. So this is the second command. After second command, you will get like this. You will get terminal like this. So this is the second command. Now third command. Now the Example Linux you will run. So this is installed. So this is the third command. Sudo npm install. Just copy this command. Now you no need. Just copy and paste that. Write the third command and press the enter. So now it will install the Example. See here. Now it will install in the Example on the Raspberry Pi. So there are some packages are needed. There are some packages we already. So by using these three commands, we install all the packages. So it will take some time. It is installing. Edge impulse. It is installing the edge impulse. So now see here, there are 347 packages is installed. So now, have you run these three commands? Akhil Arora, have you done? Remaining participants, if you have hardware, have you run these three commands on your Raspberry Pi terminal? Yes or no? Have you done? Yes or no? These three commands. Only copy paste into the terminal one by one. So Akhil Arora, sir, have you done this step or not? Remaining participants, have you done these steps or not? So now you will run Edge Impulse on the Raspberry Pi because you need to install some packages. Now, how to run? You have to write Edge Impulse Linux. That is also. So now use the below command to run Edge Impulse. So this is the command. Just copy this command, and this is paste it here. Now see here, Edge Impulse Linux. So Edge Impulse Linux client. This is the command. This is the client. So Linux client version 1.3. So what it is asking, what is your username or email address of Edge Impulse? So we have to write the same email address. See here, this is my email address. I am writing. You have to write your email address. So this is my email address. Now it is asking the password. So this is my password. It is hidden password. Okay. So now it is asking project. Which project do you want to connect this device? So I have to connect with image classification. So on my Edge Impulse, see here. This is my Edge Impulse. I already have account. This is my project image classification. Now right now the two devices are connected. So I will show you how to connect, and I will also check the devices. So now devices is see here. So I am removing these devices. See here. Because I have to, and this mobile also. See here, there is no device right now connected with my Edge Impulse. So we have to select the project. So the project is right now the image classification we created already. So we have to disable the microphone selection. So I am using this microphone. So now it will show there is some error because it is cannot find the webcam. So just we have to run this command again and it will try again. So this type of error you will get. So right now we can also connect the webcam because it is not getting. So you can connect the Raspberry Pi camera or you will connect the webcam also. So as simple Linux, we have to run again. So see here, it will found the camera. So now it is asking the device name. So right now the device name is Raspberry Pi. Okay, so this is my device name. Now it is showing here, go to the Edge Impulse. So see here, This is my device. It is showing. This is the Raspberry Pi actually. See here. The device is Raspberry Pi is now connected with Edge Impulse. So have you connected that device with Edge Impulse? Have you connected your Raspberry Pi with the Edge Impulse? Yes or no? So now I successfully connected. So similarly, we can connect our mobile also. The same process, connect a new device, same, use our mobile phone, show QR code. So I have to scan this QR code with Google Lens app. I already told you about it. So now this is the, see here. Now I click on the link. So it will show you now my device is, see here. Now my mobile phone is also connected. There are two devices. This is the status. They are successfully connected. The one device is the Raspberry Pi and the second device is my mobile phone. Because I will use my mobile phone to get the data and then we will deploy. So this is the step already written here. Raspberry Pi, we can connect our mobile also. So mobile, now click on the data acquisition. See here. So now click on the data acquisition. So here you have to select the device. Two devices, my mobile phone and which sensor. Right now I am sensing the camera. So now I am getting the, we have to connect the, we have to click the images. So right now is a computer mouse. I am classification between computer mouse and the keyboard. So there is a computer mouse. So you see here in the computer mouse, right? And we need the 25 images of computer mouse. So this is the imagine. This is the computer mouse. These are different images are there. So we have to click these images. So how to click these images? See here in your mobile phone, you have to click on the collecting images. You have to click on collecting images. So it will take some time. Now it will give access to camera. So when you click on give access to camera, now you have to click this image. See here. And in the mobile, click on the capture. And you have to write the label into the mobile. In the mobile, you have to write the label. So right now, under two labels, you have to connect the images. So see here, this is the another image under the mouse label. So in the mobile, you have to write the label. So see here, the same pictures I am getting here. See here. So I already, similarly, you can change here the label. So the another label you have to write. I already clicked the images. So another label is keyboard. So right here the keyboard as a label, and similarly in the mobile you also write the label keyboard set label. Now again you have to write the, you have to click the images of the keyboard, different keyboards. So right now see here, this is the one of the image I am clicking right now. So say same image is available, we will get image here. So when you click on the first, so see here, this is the one image that I clicked right now. So similarly, you have to connect 20 to 25 images under single label. Imagine means you have to click 25 images of mouse and 25 images of keyboard by writing proper the label under a single label, like the label is keyboard. So you have to write label in mobile and also into the edge impulse. See here, another image. Similarly, you have to click 25 images of mouse, 25 images of keyboard, or any other object. Many people do the comparison between the potato and onion, image classification. Any two different objects, you can click the images between the flower pot and the glass, Arduino and another hardware. You can click any of two object images. So now, and you can also use your Raspberry Pi. Similarly, you can use your Raspberry Pi and you can click the data. You can get the raw data from the Raspberry Pi also. So see here, just go to device, Raspberry Pi. This is the camera. Okay, so see here on the camera feed. So this is the keyboard right now. This is the keyboard, and just click on the start sampling. So see here, this is the image that I clicked from Raspberry Pi camera. Similarly, you can get data from your mobile. You can get data from your device and device with the connected hardware. So now, after this, you have to add a processing block. So how to add a processing block? So there is an impulse design. So in the impulse design, you have to see here everyone. When you click on the impulse design, you have to add a processing block. When you click on the processing block, you have to add a processing block for pre-processed and normalized images. It's optionally reduce the color depth. So this is the block they are recommended by the edge impulse. Another, you add a learning block for this is the fine tune for pre-training images classification model on your data. Just click on the add, then you have to save the impulse. So the output feature is only two, keyboard and mouse. Now click on the image. You have to generate feature of the different pictures. So the classes is only two. So right now in my case there are 54 items. You have to click 27 or 28 images of one object. So this is you have to click on generate feature. So you will get the graph of feature. Then there is a transfer learning. When you click on the start training, so it will give you, see here, when you click on the transfer learning, so it will give you the accuracy. So in my case, there is a 100% accuracy. Means keyboard is, this is the possibility. Keyboard, if you decide keyword 100% keyboard, means it is the guessing. The accuracy of that machine learning model is 100%. So similarly, now on device performance, so you need this type 346.6 kilobytes RAM. You need 585 7 KB flash, and inferences time only 107 milliseconds. Now click on the live classification. This part is very important. When you click on the, you can also see here, it is asking for the retrain the model. We can also add some data and we can train the model. So now I am retraining model because I already trained the model. Now I add some data so we can retrain the model. So similarly, we are retraining our model, machine learning model. So it will take some time. So now transfer the learning. So it will take some time. Similarly, these steps you have to do because you have to click different images. Right now, in my case, I click 25 images of mouse, 25, approx 25, 26 images of keyboard. So now we are training our model onto the edge impulse. So it will take some time. So it will take some time. Just wait. Okay. So do you have any doubt? Please ask. Do you have any doubt till now? Please ask if you have any doubt. So you can again, Nikita ma'am, you can again connect your mobile with edge impulse. So just click on the devices, connect a new device. Just again, the same, scan the QR code. You can connect the mobile again. No. So these classification models are not editable. That is from it is running on the edge impulse. It is not editable. Algorithms are not editable. So now the job is completed. So now click on the live classification. So in the live classification right now, we are writing the Raspberry Pi, the camera, and see here, this is the image, this is keyboard by the camera. So when I start the sampling, so now it is classifying. See here, it is classifying, and it will give you the result. So see here, it is 100%, it is keyboard. See here, 100% it is the keyboard. Again, if there is a mouse here, imagine this is the mouse. Okay, and I click on the start sampling. This is a live classification you are doing onto the edge impulse. Same model, now you will deploy the same model onto the Raspberry Pi. See here. Now it is confused between keyboard. 57% is keyboard because there is some shadow in the keyboard also. See here. That's why it is saying it is keyboard or mouse. So it is actually taking full picture as a data. So it is confused. It is between keyboard and mouse. So similarly, this machine learning model you are running onto the edge impulse. You trained your model. See here. What is the step? You collected the images from the mobile phone. Or you can also use the Raspberry Pi camera also. So why we connected the mobile? Because it is easy to collect data from the mobile by mobile camera. Similarly, so now you collected the images. Right now, 53 images. I'm saying just collect minimum 25 images. Okay. So then you can also, similarly, I also written here, you can get all data from the Raspberry Pi also. Now you have to design your impulse. So what is the way? Why? Because impulse takes your raw data, then do some signal processing, then extracting the features, then use a machine learning model block to classify new data. So you are adding the processing block, you are adding the learning block, then you are saying your impulse. Now, when now you are generating the feature. So there are in the training set, there are right now in the 54 items, you are creating the feature. So this is the feature explorer. Now we transfer the learning. Now you train your model onto the edge impulse. So it will give you the accuracy of the model that you create as machine learning model. So this is the accuracy and this is the on-device performance. Now click on the live classification. You will able to do the classification between the keyboard or mouse. In my case, I use two objects, that keyboard and mouse. You can use any two objects, three objects, four objects, anything. So now these are the results I already showed you. Now we have to download the machine learning. We have to deploy the machine learning model onto the Raspberry Pi. This is a very important part. This is the first part. See here, download machine learning model or deploy machine learning model on Raspberry Pi. So this is into the third PPT. Please don't get confused when you use this PDF, this PPT. So all the for step number 1, there is another PDF. For step number 2, there is second PDF. But for step number 3, 4, 5, and 6 in single PDF. So don't get confused. That's why I am saying again and again. Now the fourth step, download the machine learning model. So how to download the machine learning model? You have just open the terminal or Raspberry Pi. See here, these are the, now click on Control C. You have to stop it. First Control C. Now you have to run the machine learning model. So if the edge impulse command is already running, then hit Control C to stop it, then enter the below command. So this is the command by which you can run the, we can deploy the trained edge impulse image classification model onto the Raspberry Pi. That's why we need Raspberry Pi. People ask you why we need Raspberry Pi. That's why. Now the main objective. So this is the edge impulse Linux runner. I already given the command. You need only hardware, only simple hardware. You have to follow the steps. Now everyone, I am running this machine learning model onto the Raspberry Pi. See here. Just sorry. Actually, I copied the wrong command. Just give me one. This is the command. So edge impulse Linux runner and press enter. Now see here, downloading model. Now the model you created edge impulse. Now it is downloading onto the Raspberry Pi. So now it will take some time. Now it will taking some time. Now the same machine learning model. So see here. Now see here. Now see here the live classification. See here, it is showing the live classification is running onto this. See, I want to see field the live classification. So this is the live classification in 192.168.29. This is my IP and then this is the port number. So I am writing this same. Everyone, please see here how 192.168.29.47. This is my IP and now this is the port number, at which port number 4912. Let me check again. So 192.168.29.27 yes, 4912. Now I run this. So see here everyone, the live classification. See here, this is the keyboard. By camera, by Raspberry Pi camera, this is the keyboard. See here, what is this? Now I remove all this. Now see here, what is this? Now see the result also. Just give me, actually I am using same mobile. So see here on the result also. See here, there is a result. Now I see here. This is the 100%. It is a mouse. Now I remove this object. Now I put the Raspberry Pi. See here. Now it is saying it is uncertain. It is not a mouse, not a keyboard. It is uncertain. See here, the live model is running. Similarly, when I put the keyboard here, see here. Yes, it is 99%. It is a keyboard. See here. Are you getting everyone? See here the line. See here, if you put the Raspberry Pi or any other hardware, it will show you that it is uncertain item. Similarly, when you put anything like this is the small USB connector, this is the small, see here. So it is showing it is mouse, but it is not the mouse. So see here, this is the 100%. So it is clear to everyone. So this is the machine learning model that we run onto the Raspberry. That's why we need the Raspberry Pi. People are saying why we need Raspberry Pi. That is the reason. So and we are getting, see here, this is the answer. Every result are here also. So is it clear to everyone? Now it is clear. Is there any other doubt? So all the steps, see here everyone, all the steps is already written into this. All the steps already written into the PDF. See here, all the steps already written. Don't worry, you will get this PDF. So is there any other confusion? Any other doubt? Yes, if you have to, then yes, sir, you can store the your data in data. You have to create a database onto the Raspberry Pi. Then you have to connect that. You have to connect the Raspberry Pi with the database. You can connect, yes. But this is also live classification. So in this case, right now in this case, we are not doing the database work. We are actually classify the object on live base. Is it clear? Is there any other doubt regarding hardware or regarding any other step? So now, ma'am, we can take the queries, we can take the doubts from the participants.
So dear participants, in case if you have any doubts, you can raise your hands in the meeting and we will unmute you and you can interact with the expert.
Yes. Is there any other doubt you can ask? Yes, yes. Also. Yeah, yes. Referee can also take data from CSV file. But we have to upload data onto the edge impulse. Our target is the edge impulse. From edge impulse, we train our model. Then that trained model we deploy onto Raspberry Pi. So our target is where you can get data. So data is from mobile phone. Which sensor of the mobile phone? The sensor of the mobile phone is like camera, accelerometer, anything.
So Sony ma'am, I'm unmuting you. You can ask your query.
The mobile app means the edge impulse can get data from mobile phone. In mobile phone, there are a lot of sensors. So you will put data. So like my case, I use the camera as a sensor. Mobile phone, in mobile phone, camera as a sensor. So you have to specify the which sensor you are using.
Yeah, Sony ma'am, you're unmuted. You can ask your question. Nancy, Sony ma'am. So I guess she is not there. So we are unmuting the next participant.
Yes, you Gulab Patel sir, you can push your model from local to Raspberry Pi. Yes, you can push it. And we can also, but for training, for retraining or training, you need edge impulse. Otherwise, you have to use the library.
So next participant,
Because we
Ganesh.
are using the edge devices. For edge devices, we are using the edge impulse.
So next participant,
Not
Ganesh.
Arduino Nano 33 DLEs, and you cannot. Yes, yes, you can. Yes, you can yes, provide a real-time signal also. You can do the also the predictive maintenance. If you will get data from the any accelerometer and gyroscope, so you can do the live image, live predictive maintenance. Imagine there is a sensor on the motor and in the vibration on the motor. So you will get the data from the vibration in the motor. How? Because you will connect here the accelerometer and gyroscope. So there is vibration you will get. So there is a lot of sensors from you will get, you will give data to the edge impulse. That edge impulse train your model and you can run that model onto the your Raspberry Pi. For IoT, please for IoT you need hardware. Raspberry Pi is one of the good options, and also the some Raspberry Pi is SBC, is a single board computer. You can use the below hardware, but not you cannot do the image processing or this type of work. No, the Raspberry Pi only you are running the Raspberry, you are running the model onto the Raspberry Pi. You are training the model onto the edge impulse. You are training the model on the edge impulse without writing any library, without writing anything. How to train a model, that you have to make the library without. Raspberry Pi is industry grade. Yes, Raspberry Pi is also industry grade. Raspberry Pi is used in many industries. In your car, when you see the dashboard, touch screen dashboard, that is also running in the uh, uh, in many other IoT hardware products. We will use the Raspberry Pi. Arduino is not capable to run the operating system. Yes.
Good afternoon, sir.
Good afternoon, sir.
Yeah. By using that machine learning, for an example, if we can use it for in the domain of agriculture field, okay. If you're using that image, if you capture that leaf of that image, and can we find out the diseases of
Yes,
that
yes, sir.
plant?
Yes, sir. So you can check the health of the plant. Then when you taking the picture of the leaf after every two seconds or 2 minutes or 2 hours, you can check the health. Similarly, so by Raspberry Pi camera, you will get the images. So that images you will put onto the edge impulse. Then you train your model. Then you run similarly same model you will run onto your small hardware, very cheap hardware for Raspberry Pi. That is the objective you can do with it.
Okay, if you are assuming I have a 4 plant, okay, 4 farms, okay, each and every farm have a different thing, different type of diseases affected means, can I predict that by using the single system, by using the single Raspberry Pi?
But sir, you have to click the click the image. Also, you have to click the images. If you are doing the image classification, you have to you have to get the data from the image. Another, like if you are using want to use uh, the soil moisturing, then that time you have to use that type of sensor. So that is the thing onto the already on the devices. See here, You will connect any device. Right now, I give example. Why? Because Raspberry Pi and mobile phone. Similarly, you will connect any other hardware. If when you click on add new device, so see here, sir. These are the options by which you can upload the data. Are you getting?
Yeah. Yeah.
So see, someone asking, you can also upload the CSV file. You will also get the data from data forwarder. You will use your computer, microphone from external audio device. Right now, we are using the mobile phone, no? Are you getting? From mobile phone, we will capture movement, audio, images, and we train our model locally. There is no app required, sir. And we also connect a fully supported development board, like we use the Raspberry Pi also. Is it clear?
Yeah. Thank you.
These are the
Thank you, sir.
options. Edge impulse is not a easy, is a small tool. It is a very big tool for the edge devices like Raspberry Pi, BeagleBone, this type. Is it clear, sir, now? Is it clear? How to trace? So please perform this experiment. This is very important. You can do the object detection also with the edge impulse. Is there any other confusion? Any other doubt? Please ask if you have any doubts regarding the software. Many people are facing issue in Raspberry Pi OS installation. So do you have any doubt? Please ask.
So our next participant is Sujitra ma'am. So I'm unmuting her. Sujitra ma'am, are you there?
Yes, ma'am. Good evening, sir. I have a doubt. Is it possible for multi-label classification, sir, in Raspberry Pi?
Can you repeat, ma'am?
Sir, actually, we discussed about the binary classification. Is it possible to implement multi-label classification in Raspberry Pi, sir?
Multi-level means like?
Yeah, different kind of diseases. I'm in a position to predict different kind of diseases, whether it is healthy or diseases. I'm not talking about that one. If I'm having a 10 kind of diseases in my leaf, I'm going to predict 10 kind of diseases. Is it possible, sir?
Yes, sir. Yes, it is possible. Yes, sir, it is possible. But how you get the data? So you put the different sensors.
No, sir. I will be taking the camera images. The data,
Yes,
image data will be given as the input. Yeah.
Yes, you can classify.
And
No,
is it possible to implement deep learning algorithms in Raspberry Pi, sir?
Deep learning you can apply, but by using edge impulse, it is not possible.
Yeah, in HBUS you have chosen transfer learning. Is any other machine learning model is available, sir?
No, there is no other model available. There is also, you can check in the documentation of edge impulse. In the edge impulse documentation, you will check the different model. In the documentation, this is the documentation. So in the documentation, you will check which type of model you can do with it. So right now, there is a different model you can use. And this is the edge impulse. So you have to, this is the object detection. You have to use. You have to read the documentation.
Okay, sir. And you have taken the images, live images from the Raspberry Pi camera, and
Yes,
we can take the images through our phone also. Am I right, sir?
Yes, but you are running a model onto the Raspberry Pi right now.
Okay.
So in this tab, so see here, I already discussed this. See here, in this tab, I am, see here, man, just a minute. In this tab, see here, when I started now in this, here you will change the mobile, then you will upload any other pic from the mobile, then click on start sampling, then you will get the classification from the mobile, but not live.
Okay, sir.
You have to give different images to edge impulse, then it will classify. But when we talk about the live classification, because we deploy our model Raspberry Pi, now by run, see here, by runner command. Have you noticed the command?
Yes, sir. Yes, I noted.
That is yes. The runner command will help you to run the model onto the live as in live classification. So I targeted live classification. That's why I use the camera. You can also put the data through the mobile device, but not live.
Okay. Sir, your session is very informative. Is it possible to share the entire recorded video? It will be useful for us. Thank you, sir.
Yeah,
Thank you so
video
much.
is, regarding video, you can ask from the ma'am, and in
Okay.
technical, you can ask.
Okay. Thank you, sir. Thank you so much.
So this is already shared, I think, onto the YouTube.
We will check, sir. Thank you, sir.
This is also shared on the YouTube. Lightweight cryptography in IoT. So lightweight cryptography use the TLS or SSL we are using. So there is you can use the certification, TLS certification, the cryptography that you can use. And when you are uploading data onto the AWS or Microsoft Azure, that time you need cryptography. And there is a security weakening. This is the part of the IoT security. So that time you have to use the lightweight. That time you have to use the TLS or SSL security. That is some application you can use the cryptography in IoT. Because the security is major concern. Is there any other doubt?
Now, yes, sir. So now I request Dr. D. Gachalakshmi ma'am to kindly forward your query. Ma'am, I am unmuting you.
Hello.
Yes, ma'am.
Am I audible, ma'am?
Yes, yes, sir.
Sir, good afternoon, sir.
Good afternoon.
Sir, actually, I'm working on sensors. I have some experimental data regarding sensing of metals. Is it possible to integrate those values in Raspberry Pi for machine learning?
Which data, ma'am, do you have?
Sensor data. I'm experimentally, I got some, I got from my experiments. So is it possible to integrate those values in Raspberry Pi for machine learning?
Yes, yes. Similar, you can use this example. That is very good tool. I already discussed. So see here in the example, I told you, I already told, see here, when you connect a new device. So these are the things you can upload data. You can collect data about computer. So you have data in a file or any live data or anything, images or anything. Which data?
File, sir. File. It is a number.
Number. It is number. Yes, ma'am. You
Yeah.
can put the number in CSV, in JSON format, in PNG, anything. Yes.
Okay,
No
sir.
issue. No issue.
Okay. Okay. Thank you, sir. Actually, I am a chemist working on sensors.
Okay.
Your talk on Raspberry Pi is very informative, and I found it difficult to install Raspberry Pi. In the next classes, I will be installing it and working on it, sir. Thank you for your very valuable.
Please use, yes, please use the Raspberry Pi 4. Actually, it is not available. Sometimes it is not available. Due
Okay.
to
Sir, what is?
Yes, yes.
Okay.
Yes,
Sir,
ma'am.
what is the minimum specification of Raspberry Pi board to be bought, sir?
So, ma'am, see here, when you open the Raspberry Pi, I will, regarding Raspberry Pi, this is the Raspberry Pi, and when you visit, there is a, when you visit raspberrypi.com actually. So these are the hardware that is available. So,
Okay.
see here, ma'am, this is the Raspberry Pi 4 Model B. This is the latest one. Okay.
Okay, sir.
In India, you can watch, you can purchase from these are the two companies only right now.
Okay.
You can purchase from these. So it is approx. The price of this is approx 4100. 4100 for 2 GB plus GST extra, ma'am. So it is approx 5,000.
Okay, okay, sir.
And if you can also use the Raspberry Pi 3, but sometimes it will heat it up. Right now it is also heating. The Raspberry Pi 4 is also heating. Little bit. But it is not, because see here, when we do the live classification, we run our model onto the Raspberry Pi. That is very important. That time the Raspberry Pi is able to do. So Raspberry 3 is also okay. In Raspberry Pi 4, this is a RAM. So there are different ones. There 2 GB RAM, 4 GB, 8 GB. So you can purchase 2 GB is enough. No need to purchase 8 GB. The price of 8 GB RAM, Raspberry Pi 4 8 GB RAM is 10,000, about 10 to 11,000. Very costly. So without monitor, I also discussed, without monitor, I am using the Raspberry Pi GUI onto my screen by using the VNC viewer. I think everyone know about this if you are working with Raspberry Pi. Is it clear?
Yes, sir. Yes, sir. Okay. Sir, is it possible for adding the smileys notation in this Raspberry Pi for disease prediction? SNP.
Your voice is breaking. Can you repeat?
Sir, is it possible to give the smileys notation? I'm going to give the input as smileys notation. We have chemical structure, no, benzene. I can represent it in the form of smileys. So can Raspberry Pi can take those inputs?
Yes. That is also taken as a picture. The Raspberry Pi will take that smiley as a picture.
Okay, sir. Okay.
That image.
So once if I give that smiley, it will take as it will read as images.
Yes.
Right,
it
no,
will
sir?
read as images. So according to you have to put a lot of images under a label. So please don't forget in edge impulse. You have to write the label. When you data acquisition, when you click on the data acquisition, so here right now no device is connected. We have to connect a device. So because this is the Raspberry Pi. Right now I will connect my mobile phone. So you have to just give me 1 minute. I am connecting my mobile. So right now my mobile is connected. So when you click on data acquisition, similar, so say mobile is connected. So please you have to mention the label also. Please don't forget to, and sensor. So these are the 4 possibilities from the mobile. You can use positional, accelerometer in the mobile, microphone, camera. So right now we are using the camera. Is it clear?
Okay. Yes, sir.
Please mention the label also. Okay.
Thank you, sir.
Okay. Is there any other doubt?
Thank you, Gajalakshmi ma'am. So now I am unmuting our next participant, Nilufar Yasmin ma'am.
Hello, am I audible?
Yes, ma'am. Yeah, you're audible. You can continue.
Good afternoon, sir. Good afternoon, everyone. And we surely had a wonderful session. Sir, I am working in the field of lightweight cryptography. I am pursuing PhD in it. So far, the pioneer algorithm present, I have been able to modify it to some extent. And the results are in MATLAB. So I have been working about IoT. For IoT devices, we need lightweight encryption so that we can save power, and the time of computation is also less, and memory is also less consumed. So that is a challenge, like reaching perfectly the less cost, power, and security. So, sir, can you enlighten me about some codes that I can actually work on, and in what respect, in which devices for IoT? Because I've been reading a lot, and still I need little direction and guidance.
Okay, so in lightweight cryptography, what you are doing, enabling the application of secure encryption.
Yes, sir.
The device with the limited resources like this.
Yes, sir. So I have worked on
So,
present, that is a block cipher. So what are exactly the algorithms that we use for IoT devices? Do we use AES or DES, or there are other lightweight algorithms which I can actually work on?
okay. So,
Or yes, sir.
so imagine there is a sensor. Imagine like a camera is connected with a Raspberry Pi.
Yes, sir.
And imagine, and you have to do encryption now. Now you
Yes,
are imagine you are putting the images onto any other cloud. So now you have to do the encryption. So you
yes,
are working on that lightweight graphic. That is a size also according, because you have to run the onto the low RAM and low power consumption.
yes, sir. Low time, computation time,
So,
low energy.
okay, yes, low, and everything is a constrained model.
Yes, sir. Good throughput.
So, yes, you need a throughput. We can say the processing speed is also high. There is low delay. So you have to ask about which part?
Sir, I mean, what algorithms I can actually work on, or in what layer of IoT I can actually work? I mean, when I study about providing security to IoT devices, there are several layers. So if you can guide me regarding what layers I can work on, like should I be working on physical layer or application layer, or
So actually, in the industry, in the maximum industry, we will write the application layer code. When we are using
right.
IoT protocol, we are writing only application layer code. We are not handling the TCP/IP layer actually.
Okay.
So in the case of if we are using the application layer protocol, we are uploading data onto the AWS. We are using only the SSL security, TLS security, this type of. That is our
Right.
device is also the edge device in the small constrained device, because we are using the RM3 CPU, RM4 CPU. That is very less amount of RAM and ROM. So in the lightweight cryptography, you can do how to minimize the file size also. That is the main thing, na? Because
Minimize
you have to minimize the file the file size that you create. Imagine there is a code you created the hex file. Then
right.
then the code is running onto the device. The device is less amount of RAM and ROM. Now you have to put the cryptography to secure your data.
Right, sir.
So the first vector we can be the power, especially the layer is only the main layer. If you are asking you have to work on the physical layer. If you touch the TCP/IP layer, then you have to analysis the more factors also, because the TCP/IP layer is more complex. No one can touch only TCP/IP layer. So the physical layer is you have to work only the physical layer. Okay. It's according to me, physical layer cryptography is only you can use the another cryptography, that is so you are using asymmetric or symmetric?
Symmetric.
Symmetric. Same
Yes,
secret
sir.
key for encryption and decryption.
Yes, sir. Yes, sir. So the block cipher only, present is a block cipher
So the
only.
block cipher
Sir,
you have
I have, yes, sir. I have implemented it in MATLAB, and I'm trying to get my results from Synopsys so that I can get actual gate count, power consumption values. So, sir, how can I implement it to actually see how my IoT devices are responding to it? Do I be using some Arduino chip to see the power, or
No, ma'am, no Arduino. You have to use, ma'am, ARM M3 or M4 processor.
sir, can you please repeat?
ARM M3 or M4 processor. You can also use, ma'am, Raspberry Pi. With Arduino, it is not possible, ma'am. Because you write only the application layer code, and in Arduino or Node MCU, you will get only APIs. And there is no role of operating system. So try to use the M3 and M4 processor. ARM, M3 and M4 processor. you can use this. Okay.
So I can code my data, like some data using the algorithm I have implemented. I can actually see the power consumption or other parameters here, sir.
Yes, yes, yes. So you are using this cipher block.
Block cipher, yes, sir. Yes,
So
sir.
you can
Block
use
cipher.
ARM M3 M4, and you please don't touch the TCP/IP layer because that is more complex. So use only physical layers. My advice: use only physical layers, and you can try this with M3 or M4 processor. That is benefit. Hello.
Hello. Yes, sir. There was some connection. Yes, sir.
Yes.
So I got it. I have to study about physical layer and the processor you suggested.
So yes, M3 and M4. Try with M3. ARM M3. You will get the M3 processor in Philips microcontroller or any like ST microcontroller.
So here I can actually code my data through the algorithm which I have improved.
Yes, yes.
Okay, sir. Okay, so that would be okay.
So, is there any other doubt?
Yes, sir. There is one more doubt from a participant, Nancy Soni. So Nancy, ma'am, I'm unmuting you. Please ask your query.
Hello.
Hello, Nancy, ma'am. We have unmuted you. Please ask your query. Hello.
Good afternoon, ma'am. Hello. Hello.
Yeah, I guess she has some audio issues from her end. So our next participant I'm unmuting is Gulab Patel. Gulab Patel, can you hear us?
Hello.
Yeah, we can hear you.
Yeah, good afternoon, sir. Sir, I have a question. Here, if I see age impulse, so you are using pre-trained model, right? Suppose I want to use some custom model. How can I use that?
So that time you have to develop library for machine learning.
Okay, so one more question. Can we connect this Raspberry Pi with GitHub or Bitbucket or any cloud services like GCP or Azure?
Yes, sir. You can connect.
Okay, then we can use the trained model over there and
Yes, yes.
okay.
Impulse is only for those when we would not need any another library. So as Impulse is giving you the model, and you train your model onto their cloud,
Okay.
and that model will give you that model you have run onto the Raspberry.
So the trained model on GCP we can upload on its Impulse, or we can directly connect Raspberry Pi to GCP.
Yes, sir.
No. I think you didn't got me. So that trained model that we have on GCP, we need to upload on Edge Impulse, then connect to it.
As Impulse from As Impulse, we connect our Raspberry.
Okay, got it. Okay, thank you, sir.
So thank you, Gulab Patel. So with this we come to an end, sir. So there are no queries from the participants.
There is one thing. For tomorrow hands-on, we need Node MCU, please everyone, and we have to install the Arduino IDE. We need Node MCU for tomorrow hands-on number 2. This is tomorrow. There is hands-on number 2. This is hands-on number 1. So on day 3 there is a hands-on number 2. So we need Node MCU, and I will share the list of the hardware and some software installation guide also.
Yeah, hardware list is already shared with the participants in the schedule.
Yes. So
Yeah,
that's why
only
I'm saying you need LDR, you need register, you need node MCU and a good Wi-Fi internet. This is our tomorrow hands-on number 2. And Raspberry Pi we will need in hands-on number 5. No, hands-on number 6. That on next Tuesday. Is it clear, everyone? So now we can conclude our session.
Okay. Thank you, Jitesh Kumar sir, for your wonderful session. So tomorrow's hands-on details and software installation will be shared by sir. So once he shares, we will share it among all the participants. It will be uploaded in the Drive link. Today's session materials will also be uploaded as the course progresses. Today's hands-on session will be uploaded right after the session, right after ending this meeting. Attendance link will be updated by end of the day. And tomorrow, all the participants are requested to please connect by 10 o'clock through the same link. Please note that the attendee link is will be the same for all the session for all the 10 days. So we request all the participants to please join the session tomorrow sharply by 10 o'clock through the same link. In case of any queries, you can let us know in the Telegram group. The Telegram group will be active from 9 to 6 p.m. From morning 9 a.m. to 6 p.m. respectively. Thank you. So with this, we come to an end to day 2 of this online faculty development program on Internet of Things and Applications. Tomorrow we will join by 10 o'clock. Please note that the recordings, not recordings, we can say that the entire session is going live every day in the YouTube channel of ICT Academy, IIT Guwahati. So the playlist is already being shared with all the participants in the important announcement page. So we request all the participants to please refer to the videos which will be uploaded in the YouTube channel after the end of the session. So with this, we come to an end. Thank you all the participants for joining and making this day 2 so successful. Thank you all. Thank you, Jitesh Kumar sir. Thank you for this wonderful session. From the entire team of ICT Academy, I thank you for joining today. Thank you all. Nagarani ma'am, there is no assignment. No assignment is there. Kindly note this thing. No assignments is there. Only MCQ will be provided to the participants. First MCQ will be on 18th of February and second MCQ will be on 24th of February. So no assignment will be there in this program. So we request all the participants to please disconnect and the meeting link will be deactivated in another 2 minutes. Okay, Manoj sir says about attendance. Yes, sir, the attendance, as we have already informed, attendance will be uploaded today by the end of the day. And it will be notified in the Telegram group also. Thank you. Thank you all. So we request all the participants to please disconnect from your end. The meeting link will be deactivated in another 2 minutes. Thank you. Thank you all for joining. Yeah, Manoj sir, the feedback form will be provided to you on 25th. That is on the last day of the program. It will be an overall feedback of the entire program, sir. Thank you. Thank you for connecting.